We're introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development.
So you know that no matter what platform the user is on, tasks are scheduled efficiently and with system-wide health in mind.
And we're just getting started.
Be inspired. Isn't that something?
We're excited to be here at GDD India meeting some of our certified alumni. Morgan, how are we doing with the program?
We're doing really well. We have nearly 300 Indian alumni here, and it's been really fun talking to all of them.
Yeah, it's really great to hear the stories of leadership, people making connections, getting jobs, promotions. We're just excited for everything that the alumni do and more.
So I have attended like 2 to 3 Google's event in Mumbai, but I have never came to this big event, and this event is very awesome.
It's my dream actually to be part of this events and all, meeting Google people.
And my favorite part was being in the launch in the open area where everything was being demoed, and I met other people near the certification launch.
We have a huge community of people who respond and react to your questions and queries day in, day out. Other than that, we have the Google developers themselves from the Google groups who respond to queries.
Our largest group of alumni are from India. We have about 300, and it's constantly growing, so it's great to be here in person and meet the biggest part of our alumni group.
After getting my certification, the way people interview a candidate changed, and they were really interested in the person who has the certification directly from Google. And finally it ended up me in the job that I wanted. A couple of offers and I get to choose one.
The organizations nowadays ask if you are certified dev, okay, come forward and we'll have an interview with you.
Before this certification, I was not very confident about my skills, and after certification, then I came to know about myself, what is my level of coding, and I get confident about my developing skills and Android skills.
These certifications are all based off of a job task analysis. This means that we've gone out into the field and we've talked with people who have these jobs as careers or who are currently hiring, and basically we've asked, what is it that you are looking for when you're hiring an associate level Android developer? So all of this combined really creates a unique certification experience.
And from my companies and all, I'm getting more value actually because I'm certified from Google.
We have been highly appreciated, and they said that this is a good thing because it's not just a personal achievement, it's an achievement for the company also to say that we have not just developers, we have certified developers working with us.
So I've been working for 3 years as a backend developer, and now I'm going to be a full-time Android developer. I'm going to start from day after tomorrow.
I have proof that I am an Android developer, and Google has tested my all skills, and then I have this badge.
Welcome, everyone. Please take your seats. The program is about to begin. As a courtesy to the presenters, please mute all mobile devices. Everyone, please give a warm welcome to Chet Haas.
Howdy. Welcome to another Android Developer Summit. So how many people went to the last one? Pretty good. How many people enjoyed the last one? Same number of hands, which is awesome. We also really liked it here, which is why we did it immediately again 3 years later. We were just sort of building suspense to make it extra special. Hopefully, we'll get to do this again. Let's see if this works this year. A lot of this content, most of the content is being live streamed. All of it is being recorded. If you prefer consuming this through a live stream, I could just sort of awkwardly pause occasionally and then buffer, and then maybe that would make it more of a live stream situation for you. I am Chet. I lead the Android Toolkit team, and for some reason I'm emceeing today. The trick with emceeing is to go long enough, make it sort of a nice enough event, sort of tie things together, but short enough that everybody doesn't get really, really tired of the MC. So I'm going to get on and tell you some things about how this thing is going to work today. So some logistics, Dan went over some of this. I'm going to repeat it because I'm going to assume you listen to keynotes about as much as I do. So the most important one to me is office hours. So there are two reasons that we like to have these events in Mountain View. One is because Mountain View is such a beautiful city with so many interesting things to do, don't you think? That's what we all think. We live here. Every day we're here. So obviously, Mountain View for the culture. But the second reason is Google is just up the street, which means we can drag a lot of engineers from the team that build all of the bugs that you're now dealing with into the product. And we like to bring them into the conference to help answer all your questions. The key thing for you to know, though, is all of those people aren't here all day. We've broken up the event into 4 half-day sessions, and there are different people in different teams and different technologies represented at different times. So there are 3 schedules posted. There are screens around the conference. This is one of the screens. If you can't read this, then maybe you can read the screens outside the room instead. Go check the screen. There's a rotating schedule there. It'll show you when people are on where. and make sure, oh, well, you know, I have a question for the location team or whatever it is, make sure that you go at the right time. Also, you're encouraged to go ahead and skip sessions if you want. They are being recorded and catch them later. The people are at the office hours all day in all of those sessions. So go ahead, make your time, ask the right questions, find the people. They are probably here at the right time. There's also app review clinics. There's demo pods. Be sure to check those out. Let's see, there is the live stream stuff. There's also a hashtag on Twitter if you're following any of this content or broadcasting any information, Android Dev Summit. There is an application. I assume that you have this already. If you do not, I just found out yesterday, it's an instant app. So do a search in your favorite search engine and click on the link for the instant app, and it downloads and runs instantly. It's like it's advertised. So that's pretty cool. There is a party tonight starting immediately after the session, sometime after 6 o'clock. That'll kick in. Party with a bunch of other engineers where we all have the excellent experience of talking to each other while the DJ is playing loud music and having conversations that go along the lines of, what? What? So enjoy the party. Enjoy those deep conversations with the new friends. And that's about it. I am no, one more thing. So there are 3 different session lengths. There's the long sessions, 40 minutes. There's shorter sessions of 20 minutes. The intention is to link these things, and you will go for both of them in one slot. It's a little bit awkward to get up in the middle of the crowd and move out in the middle of one of these things. So we're about to see 2 in a row here. Please stick around for both of them, or if you really do need to leave to get to one on the other side, just try to do so quickly and quietly, because we're just going to roll from one end to the other. And then there's also lightning talks, 5-minute talks that start at, I believe, 12:05. And we'll run for an hour, and those are just going to go back to back into each other. So stick around for those, and that is about it. I am standing in the way between you and actual real technical content, so I'd like to bring up Matthew Garrity to talk about Lint. Thanks.
All right, welcome. Yeah, let's get started. My name is Matthew. I'm actually on the Android Studio platform team. That means I work on things like product stability, Kotlin integration. Let's go next slide. Hold on. Just a moment. And one of the most exciting things I get to work on besides product stability is something called Android Lint. So that's what I'm here to talk about with you today. So Android Lint is actually a very powerful tool. I think a lot of you already know about it, but you might not know all the cool things that it can do. So despite the name, it's not just a linting tool. It's actually like a full-fledged stack analysis framework. And it's really powerful. You can write your own checks, and I'm going to talk about that today. Yeah, no worries. This talk is really for anyone kind of really interested in programming languages, compilers, stack analysis. It's also for anyone who has had to deal with bugs in the project. So I think that covers the rest of you. Oh yeah, one last thing. I only have 20 minutes, but there's a lot of material, so I'm going to go kind of fast through some of these slides, try to keep up. The good news is that at the end of the day, you can go home, you can watch it on half speed on YouTube, and you should be able to understand some of it then. Perfect. Don't worry about the speaker notes, actually. All right, let's get started. I'm going to go extra fast now, so let's keep up. All right, so what is Android Lint? Like I said, a lot of you probably already know. Even if you don't know the name, you actually do know what Android Lint is, because it's the thing that shows up warning messages in your IDE saying, hey, you're doing something wrong. And so in some cases, this is like telling you, hey, Gradle might be out of date. Do you want to update it? Or maybe you're not calling a super method in a method that expects you to do so. And right in Android Studio in the IDE, it'll say, hey, there's some code here, looks suspicious. Maybe you want to take a look. And sometimes it's warnings, sometimes it's errors that will actually fail the build. So some of you might not know, but there's actually a lot of different ways to use Android Lint. First one is on the fly, which is what I just mentioned, where it's kind of in the IDE. As you're typing, it shows error messages right away. You can also do something called inspect code. This is an action in Android Studio where you can run a batch analysis of your entire project. It's a really great way to kind of audit your project for common errors. And a related action called run inspection by name. So if you have a particular bug in mind, say you want to find a lot of thread annotation violations, you can run that inspection by name, kind of audit your entire projects in one batch analysis, and look through those one by one. Some of you might not know, actually, though, that you can also run lint at the command line with Gradle. So you do something like Gradle lint debug. That's one of the tasks that we have. And it's kind of the same thing. It'll just do a batch analysis for your entire project. And the really great thing about that is it'll make a HTML and XML report. So you can parse the XML report if you want to do something fancy with the results, or you can just take a look at the HTML report and go through your warnings. So even if you know what Android Lint is, I really want to do a deep dive into kind of the advanced use cases for Lint, because it's a very powerful tool. So first, I'm just going to talk about configuration. Kind of sounds boring, but it's actually really important for big projects. You want to make sure Android Lint is working for your project and for your needs. I'm also going to talk about annotations. It's a really powerful way to kind of mark up your code to help Lint help you even more. So kind of Lint automatically does as much as it can, but sometimes you need to tell it, hey, you need to give it hints to help you even more. Also going to talk about Lint internals. I'm really excited about this part because I really want to give you a good mental model for how Lint works under the hood. This will get you set up for kind of realizing how powerful of a tool it is, and also for writing your own custom Lint checks, which is actually the last step. And that's kind of the fun demo part. All right, so let's talk about configuration. The easiest way to kind of see what Lint is capable of is to go into Android Studio, open up Preferences, go to the Inspections window. You'll kind of find a heading that says Lint, and under there you can see all of the inspections that Lint has. There's actually hundreds, and most of them are enabled by default. But there's actually some that are not checked by default. And I encourage you to kind of just explore these, take a look at them, because some of these might actually apply to your project, even though we don't enable them by default. A really good example of this is something called Kotlin interoperability. This is just a set of checks that we created so that you can call Java code from Kotlin code and vice versa. And if you do things that makes that difficult, then Lint will actually warn you right in the IDE, like, hey, you might want to rename this function so that it's easier to call from the other language. There's actually another way to configure Lint, which is with Gradle. So if you go into your build.gradle file, you have this Android block, as you know. But you can also add a Lint options block. And there's some really powerful options here. So this first option, I'm just going to go through a few examples. This first option here is a really powerful tool. Anyone with a really big project, you really want to pay attention to this. So a Lint's baseline is just kind of like, when you add this to your options, Lint will take a snapshot of all of the warnings and errors you currently have in your project. And what this will do is it'll give you a clean slate. So you'll say, like, hey, I want to take a baseline at this point of the project and forget about all of the thousands of warnings that I already have. And then I only want to look at new warnings and errors coming in and new code that my team checks in. And this kind of helps you get a handle on the massive amount of code that you have and still be able to have clean code going forward. And then when you have more time, free time, you can go back and look at all the baseline issues that Lint has stashed away. Once you do that, so once you have a clean slate, either through a Lint's baseline or because you have a new project and you just want to say, hey, I want to have clean code forever starting now, you can turn on warnings as errors. I really encourage you to try this out. It might not be for everyone, but if you care about clean code, definitely try to get this to work for you. And then, like in the last slide, you can enable specific checks that are not on by default, like interoperability. So some of you already have this Lint options block set up. And some more advanced things I want to talk about is performance issues. So one of the reasons we have this Lint options block in Gradle is because a lot of people run Lint on their continuous integration server. And so they're constantly checking their entire application for Lint warnings, Lint errors. Maybe they even block pre-submit if you have a new warning that someone just checked in. But some people are kind of concerned about performance. So just a few tips here real quick. Try to avoid the check all warnings option. I know it's really tempting. I just told you how to enable more checks. But actually, some of the checks are off by default for performance reasons, for example. So if you check all warnings, like you can say, oh, man, my time to check the project is just doubled. But be a little bit more selective in the checks that you turn on. Also try to avoid the Gradle Lint tasks. It's actually a parent task of multiple subtasks, one of which is like Lint debug or Lint release. The parent Lint task will actually run lints multiple times on a project for each build variant. And so that's just a really simple gotcha that you should try to avoid. Also, if you can, use the ignore test sources option. So by default, we already don't look at your test sources for warnings or errors. The theory being that you don't really care about how clean your tests are. But this option will actually make it so we don't even parse your test sources at all. And so presumably all of you have really, really well-tested code. So this option will help with that and make things go faster. All right, let's switch gears a bit. I want to talk about annotations. Annotations are a really powerful way to just give Lint hints for specific issues that you want to look for. So I'm just going to go for a few examples. A lot of you already know about the nullability annotations. Hopefully, you've used this a lot in Java. In Kotlin, you don't need them because it's kind of built into the language. But we also have really Android-specific annotations, which you should check out. So there's one called requires permission. You probably know about this one too, but it's just an example where we kind of annotate certain Android APIs with requires permission, maybe like the set wallpaper permission. And then Lint will actually kind of do some analysis on the code that calls into this API and say, hey, is the programmer actually checking that they have this permission? If they don't, then we can warn you, like, hey, it looks like you haven't checked that you have this permission. This might crash at runtime, and this impacts users quite a bit. There's also one of my favorites kind of annotations, which is UI thread and worker thread annotations. I think they're just called thread annotations in general. These are really important, actually. So a big problem with application development is a lot of UI frameworks require that you only update the UI on a single thread called the UI thread. And everything else has to be done on the background thread. So if you do a network request, you have to do it on the background thread. Because if you do it on the UI thread, the network request might block. You'll freeze the UI. User will be frustrated. You might not even see a crash report. And it's really hard to track down these issues. So we have these thread annotations where you can say, hey, this method should only be called on the UI thread or should only be called on a worker thread. And we have some analyses to track that down. So I'm actually going to do a demo of these analyses. Hopefully that's set up. So let's switch over. Can we switch over to the demo? Perfect. Awesome. So use your imagination a bit here. I'm going to go through an example. This is just Kotlin. Let's say we have a function. Oh, the screen is black. You're right. It was there for a second. Awesome. Let's get started. So let's say we have a function called update UI. Obviously, we expect this to be run on the UI thread, so maybe this is updating the user interface, whatever you want. And then let's say we also have a function called network requests. So just a really contrived example. And this does some stuff. All right, and unfortunately, someone decided to call a network request from the update UI method. So this is a problem, right? As you can see, there's no errors or warnings. Threading issues like this are actually really hard to track down in general. But if you know about these thread annotations, you can add the UI thread here. You can add the worker thread annotation here. And instantly, Lint will say, hey, you're trying to make a network request on a UI thread. That can freeze the UI. You don't want to do that. So that's really, really powerful. I really encourage you to use these. Now, you might be thinking, hey, this is a really contrived example. This is too simple. Actually, what we have in our application is this UI method that calls a function foo, maybe. And then that function calls something called bar. And then that bar function calls the network request. There's just multiple layers of indirection here. And you're thinking, oh, Lint can't help us here, right? And as you can see, it can't right default, because for performance reasons, we don't try to do these advanced analyses. But actually, we do have an analysis for this. So I'm going to show you an example of that. You can do run inspection by name. The name of the inspection is called wrong thread, and then interprocedural. If you select that, select the scope. I'll just say module scope. And bam, it'll find the call path from foo to bar to network request. And I know you can't see this error message down here, so let me copy it for you. And I'll remove the class names. And so you can see the error message shows you, hey, you're starting update UI, you're going to foo, you're going to bar, and then you're going to network request. And that's annotated with worker thread. And that's an issue. All right, let's go back to the slides. So please check those out. That analysis is off by default for the main reason being performance. It's trying to do a whole program analysis. It's pretty expensive, so just use it when you can. Just try it out and see if it finds any bugs in your application. All right. So next I'm going to talk about Lint internals. This part's really cool. So the way Lint works is it starts out by parsing your source files. So maybe you have some Java, Kotlin lying around, kind of builds the abstract syntax tree. And the first thing we do with that is we actually wrap it in something called UAST, which stands for Universal Abstract Syntax Tree. If you've dealt with these kind of things before, that might sound pretty familiar. But this step is really important because it means that when you write a check, you only have to write it once, and it works on both Java and Kotlin. And that's really convenient, actually. And then when you write a Lint analysis, you're actually just operating directly on UAST. So when you write a Lint check, you're just kind of scanning the UAST for your source code. You're looking for method calls that you're interested in. You're looking in expressions that you're interested in. And that's how it works. It's also important to point out, Lint actually works also on all types of files. So you can look at Gradle files. You can look at XML files and resources. This is actually really powerful because it kind of gives us a holistic view of your entire application. And we can provide a lot more helpful warning messages with that. A couple more points here. So type information is available. It's not just, you're not just looking at text. You actually have the whole AST with type information. You can do things like method resolution. You can do things like examining the class hierarchy of the class you're looking at. That's really important for preventing false positives and just having really powerful Lint checks. That's kind of what makes Lint so useful. We also have really tight integration with the IDE. So one of my favorite parts about Lint is that it actually does show you the warning messages right in the IDE. I think that's critical because if you don't have that, then a lot of your warning messages would just be lost in some build output somewhere, and it wouldn't be useful to most people. So with that, we're going to move into writing custom Lint checks. And what this means is that Android Lint is actually a framework. You can write your own Lint checks. If you have something that annoys you, like either a common bug that you run into on your team or just something that you want your colleagues to watch out for, you can write your own Lint check. You can upload it to your code base, and all your colleagues will see it in the IDE, things highlighted. Quick note here, Lint actually has an unstable API. All this means is that we don't promise that we keep it the same from release to release. The good news is that it's not changing too often, but no promises. The other good news is that unstable APIs are really fun to play with. So, all right, and with that, we're going to move into the demo. So let's switch over. Awesome. Much faster this time. All right. So don't bother reading code too much. The example I want to set up here is that you see that your colleagues are maybe calling thread.yields pretty often. And if you look at the documentation for thread.yield, it's actually not a very useful method. I mean, if you're writing very advanced concurrent data structures, maybe it's useful. But in other cases, you really want to avoid it. It usually doesn't do what you think it does. So let's say we want to write our own lint check that actually catches calls to thread.yields and warns people that they're doing that. So right now, it's not highlighted. There's no lint checks yet. I want to show you how I have this set up. So you already have some kind of Android application module here. Here it's just called app. The way you're going to write your own lint checks is all you're going to do is you're going to make a Java module, maybe called checks, for example. And you're going to add a dependency from your Android application to the checks module. And we have this nice lint checks block here, which will make it really easy to do that. Once you have that set up, and I know I'm skipping over some of the details here, but I'm going to have some links at the end that you can look at sample projects. So once you have that set up, we can actually go right to the lint check itself. So here I have a class called yield detector. As you can imagine, this is a detector for calls to thread.yields. It extends some classes in the lint framework. And I already have typed up some of the metadata for this check that we want to have. So there's a name, there's a brief description, and there's an explanation for like how to fix the issue. Maybe there's a severity, whether it breaks the build, et cetera. So once we have that metadata, I'm actually going to start typing some code here. So one method to be aware of is called getApplicable method names. So the way lint works is, there's a couple options. You can either make your own AST scanner, which kind of like just give you total control. You can scan the entire source file, look at it for whatever you want. But for performance reasons, we have these hooks where you can register with lint, like, hey, I'm only interested in method calls that have this particular name. And so here, we're actually only interested in method calls with name yield. And if I have any typos, it's not going to work. So let me know. Once you have that hook in place, we have to write the hook itself. So here we can say visit method. And I'm going to make sure that's readable for all of you. So this method should really only be called when we come across a yields function call in the source code. So we can say, like, OK, let's assert that the method name we're looking at is actually yield. So this should always be the case. And then because we have type information, we can do due diligence and make sure that we don't have a false positive here. Because maybe there's another class with the function called yields, and we want to make sure that it's actually the Java lang thread.yield. So here we're going to check. We have some helper methods. I'll type it out. If you look at the evaluator, you can say is member in class. We're going to pass it the resolved method node, and then we're going to give it the class name. So java.lang.thread. This just means, if this method that they're calling is actually part of this exact class, then we can report the error. And then I'll say context.report. I'll give it the issue that holds the metadata we have above. I'll give it the node. I'll give it the location. So we're telling Lint, like, hey, here's where the error is. This is what you should highlight. And I think I have to give it a message. So let's say, please don't use this. Obviously, you should use a more helpful error message. All right. That's all it takes. If I have no typos, I'm going to make the project. Looks like it's done. And if I go back to our application, bam, Lint has already scanned your source code. It's already picked up your Lint check, right in the ID. It says, please don't use this. And that's really powerful. You can make this pop up for your colleagues and everything. So awesome. Let's go back to the slides. All right, 50 seconds left. I'm pretty happy with the timing here. Here's some links. I really want you to check these out. So if you've never read the Lint overview on our developer page, please go there. It's got a lot of information, both from this talk and a little bit more. Please check out the annotations page. I just touched on like 3 random examples, but there's so many useful annotations that can really prevent a lot of bugs ahead of time before your users ever see them. If you are really excited about this demo I just gave at the end here, check out the sample project we have on GitHub, where you can actually write your own custom lint checks, and it'll kind of get you up to speed. And finally, if you run into any issues, we have a Lint mailing list where you can go to for help. Many of you might know Tor. He's pretty active on the mailing list, and I'm pretty active on the mailing list too, where we kind of answer all the questions that get asked there. All right, and with that, thank you so much. If you have any questions, don't ask them now, but I'll be out in the sandbox area afterward, and I'll be happy to answer any questions. So please check out custom lint checks. Thanks.
Good morning, everyone. It's great to see so many people here interested in testing. My name is Jonathan Gerish, and together with my colleague Yuki Hamada, we're going to be presenting a session on testing APIs today. So just to get started, just hands up anyone who's written unit tests. It's not a trick question. Good. And what about integration tests? You can be honest. Awesome. OK, let's get started. Click. OK. Try. Click. Sure.
Is this in any way related to Project Nitrogen?
There's actually a Project Nitrogen talk tomorrow. It's near the end of the day. I'd strongly encourage checking it out. But the talk we're introducing today is it's part of the grander vision along with Project Nitrogen. They sort of work in conjunction. Any more questions? We can do this in reverse. So. Click. Yeah.
So, John, so you can click, but there's no notes for the moment.
OK.
Yeah?
Sure. We'll just ad-lib this. OK. So on Android, there's 2 kinds of tests you might be familiar with. There's local unit tests, and then there's instrumentation tests. So let's start by looking at local unit tests. So these are ones that these are tests that are executed on your local developer's workstation on the local VM running there. And because you don't need to run the entire Android build chain, you avoid dexing and packaging and installing on a device, these tests are actually really, really fast. On these kind of tests, you can use a tool like Roboelectric, which comes with its own set of testing APIs for setting up the state of your Android environment. Or you can use a tool like Mockito, and you can stub out the interactions with the Android framework. And either way, they allow you to write tests setting up the state of the environment that satisfy the preconditions that you might want in your test case. The second kind of tests are instrumentation tests. Now, these are the tests that will run on a virtual or a real device. A real device could just be a phone connected to your workstation, or it could be a farm of devices somewhere in the cloud. These kind of tests run slower because you have to execute the whole build chain and install an application onto the device. But they have the advantage of being a lot more accurate because the real or virtual device is very similar, or in some cases identical, to devices that your users will be using out in the field. And this brings you the confidence that your app is going to behave as you expect. One criticism we have heard is that on these kind of tests, there's actually a lack of testing APIs available, which makes it difficult for you to set up the state of your environment in a way that satisfies certain preconditions or edge cases that you might want to be testing. And so we've heard you loud and clear, and this is something we're actively working on. So a bit of a little history lesson. On 2017 at Google I/O, we presented what we call the Android testing story, so based loosely around like the software development pyramid. And in this model, we encourage you to write lots and lots of fast, scalable unit tests that test all your exhaustive conditions. We encourage you to write a smaller number of instrumentation tests that will actually prove that all these units assembled together behave as you'd expect on a real device. And in some ways, this was kind of a compromise. It was a compromise between the advantages of one kind of tests and the trade-offs of another. It sort of brings you like a holistic way of testing your app. And we showed how this kind of approach can lead to test-driven development on Android. First of all, you would start with a failing UI test. This would be an instrumentation test, probably written with Espresso, and it would test the UI of your component, your feature. And then you would satisfy that feature by a series of units, classes, coming together, their interactions. And you could test drive these as well using a tool like Roboelectric or Mockito running as a local test. And this gives you very fast development cycles. Finally, when you bring them all together, you're able to run the slower running but more faithful instrumentation test, and hopefully it goes green, and you're done. Well, we enter a refactoring cycle because maybe your code leaves a little to be desired and you want to do some cleanup. So you can spend some refactoring cycles there before coming around to the beginning of the cycle, where if you have any more work on the feature, you might add another test another aspect to that feature, and you'll keep iterating until you're complete, at which time you're good to submit your code and move on to the next task. So at Google I/O this year, we realized there was somewhat of a test writing crisis. And because there's so many tools available, it's not always clear which one to use. And each of these tools all have their own different styles and APIs and paradigms for the same concepts that exist on Android. And the problem with this is that tests written at different levels are not portable across levels. Your test is kind of stuck. It's coupled to the testing tool and the environment that you've written it on. So this year at Google I/O, we announced a beta of AndroidX Test. It brings testing as a first-class citizen as part of the tool chain, as part of Jetpack. And it would include some of the existing libraries you've used before, some new APIs, some full Kotlin support, which allows you to write really beautiful and concise tests, and it's available on and off device. Well, last week, AndroidX Test moved out of beta into the first full and final release, 1.0. It's also, as of last week, fully open sourced, so we look forward to welcoming your contributions. And all of the documentation on developer.android.com/training/testing has all been revamped to show you the new styles of APIs. So please go and check that out. So let's take a look inside. The first module that we pulled across was the existing JUnit 4 support, the runner and the rules that you may have used before. We've also added a new module, which we call Core, and this includes some new APIs. Application Provider, as its name suggests, it's a quick and easy way to get hold of the application context. Activity Scenario, which is a brand new API that provides coarse and fine-grained APIs for which you can test your activities. And Fragment Scenario, which was released actually just this week, providing a very similar set of testing features for fragments. We've also brought Espresso into the Jetpack AndroidX family. Espresso, if you're not aware, is a set of view matching, a library with a set of view matching APIs and a set of view actions that allow you to match and then interact with those UI elements. It also includes some other things like ability to capture and stub intents for the system. And finally, we've also released some Truth Android extensions. And Truth is Google's open source fluent testing assertions library. And we brought in a bunch of components for Android subjects, which allow you to test your Android objects in a way that reads beautifully and concisely. And those of you who've been using RoboElectric will know that we've had a version 4.0 in beta for a while. And as of last week, we did a simultaneous release that's now gone into final. RoboElectric 4 fully supports all of the unified APIs that are in AndroidX Test, as well as a number of its own new features and improvements. OK. And so I'd like to welcome Yuki on stage, who's going to give you a deeper dive into some of the APIs available. Yuki? There you go.
Thanks, Jonathan. Hi, everyone. So let me introduce our new APIs. Let's start with Application Provider, which is a new way of accessing context from your test code. Okay. So when you work on Android testing, you need to handle two different context objects. The first one is come from application. Sorry, the first one is come from application under your test. And the second one is come from the instrumentation APK, where your test code is stored. So with today's library, we have two different methods to access these context objects. And this makes your test code harder to understand, because the library uses library-specific terminology. Target context means context from your instrumentation APK, while the target context means the context from your application, while get context means the context from your instrumentation APK. Also, it is not obviously which one to use for your test. So in our new API, we hide the instrumentation context from public API, and we only application provider only provides application context in the form of your application class. Let's take a look at the example code. So here, let's say we have a test for the location tracker activity. And in the setup method, we get the target context in an old-fashioned way, and we typecast it to a location tracker application so that we can register a mock object for testing. And second line, set the mock object for that. And this code is pretty simple, and it actually works. But you could have used a wrong context and faced the runtime error and ended up with wasting your time for debugging. Now, with the new way, application context provider provides your context in your application class. So you can do exactly the same thing, but there is much less chance for confusion or bugs. OK, let me move on to the more complicated stuff, activity scenario. Actually, before we dive into details, I have a few questions for you. How many of you have written your own activity and handle the lifecycle transitions by yourself? Please raise your hand if you are. Cool. And how many of you have shipped your activity with the bugs related to lifecycles? Oh, many of you. And who didn't write a test for that? Who did not write a test? Cool. Well, yeah, I see some hands are keeping up. And to be honest, I did too. And I agree. The writing tests for the activity lifecycle transition is pretty hard. And there is no such a good API in the testing library as now. So that's why me and Jonathan and our team have sought for a solution. And we developed the activity scenario, which you can use it for driving your activity state to an arbitrary state for testing. So let's revisit the activity state first. So the created state is where an activity is created, instantiated, but it is not visible to users yet. Or activity can be created state while it is running in background as well. And the started state is where an activity is created and started. It's partially visible to users, but not the foreground activity. Activities running in picture mode is also in this state. And the resumed state is where your activity is fully visible to users and running in foreground. And Android framework can change the lifecycle state by any time by the user interactions. So your activity has to handle those state transitions properly for a good user experience. Otherwise, you'll see some bugs. And the activity scenario provides a method, moveToState, which you can drive your activity's lifecycle state to an arbitrary state for testing. Let's take a look at an example code. Here, we have a test for a location tracker activity. And here, we want to verify that location listener is properly unregistered from the system when the activity becomes created state. So at first, we have to start the activity. Launch activity takes your activity class and start the activity and waits for it until it becomes resumed state. And moveToState initiates the lifecycle transition and moves the lifecycle state to the created state. Also, all the activity scenario method works as a blocking call. So after this method call, it is guaranteed that the activity's lifecycle state to be created. And then you can inspect your activity's internal state by calling onActivity method. Yes, that's easy. Now we have an API. And also, you can use activity scenario for testing a recreation of your activity. So activity recreation happens when your activity is running in background for a long time and when you come back later. And your activity has to save its internal state to a saved instance state bundle before it is destroyed. Otherwise, you will lose the state. And activity scenario has a method, recreate, where you can use it for testing such a scenario. Let's see an example code. So here, in this test, we want to make sure the input text is restored properly after the activity is recreated after destruction. So first, we have some test data, like test user, as an input. And again, we start the activity. And then we input we fill the text box by using the Espresso library. As you can see, the activity scenario works pretty nicely with Espresso. And then we call recreate, which actually destroys your activity and recreates the new instance and waits for the activity to be resumed state. And then, again, using the Espresso again, and we can make sure that the text is there as we expected. Yes, it's also simple. Okay, finally, I'd like to show you one more example from the truth extension. Intent subject. By use of intent subject, you can verify your intent values, and it produces really good human-friendly error messages if the error happens. Let's see an example code. In this time, we want to again make sure that we want to make sure data intent has an expected contact name in its extras. So first, we create a bundle of the data intent. And then we assert by 3 lines. One is checking if that intent has expected action. And the second one is type. And the third one is the extra bundles. And if the value doesn't match your expectation, you see this error. As you can see, you can immediately know in this example, the intent action is not what you expected. And there are lots of components come with AndroidX test 1.0. I can't show you everything today, but for example, we have more assertions, and we also have Android builders where you can create your testing data easily, and also scenarios for activity and fragments. And you can take a look at this link or documentation to see more. I hope you to try it out after the talk. OK, so this is our solution for the test writing crisis. So with unified API, you no longer consider whether to write an instrumentation test or the robolectric test, because you can now just write an Android test. And that test runs on both runtime environments nicely. So with the unified API, you can focus on what to test, and you can forget about where and how. And to ensure the consistency of the behavior of our API, we have a verification test, and we run the same test against the we run the same test on locally with Robolectric, and also we run our test on virtual devices from the API level 15 to the latest version. And let's go back to the workflow we showed you earlier in this talk. So we can execute the test-driven development much more efficiently using the device-agnostic test. That's the test writing in a unified API. As our recommendation, we recommend that you write the test and run the test with the Robolectric, and then until your code is ready to submit, and then run the same test, but on the virtual devices before actually you submit the test to maximize your confidence. Also, you can run the same test as a continuous integration test against the nightly built binaries. With the upcoming nitrogen tool chains, you can set up such a configuration easily. If you want to know more about the project Nitrogen, we have a session tomorrow, and we highly recommend attending it. Cool. Thank you very much for listening, and have a happy testing.
Hey, everybody. I love that interstitial music. I think the point is to make you really happy when the next presentation starts, so they shut the music off. We're going to do something new. We're going to do lightning talks, which we haven't done before, so let's see how well this works. The way it's supposed to work is we're going to roll from one into the other. They have 5 minutes to go, and when 5 minutes is up, then I will call time, and in the back they're going to press a magic button that makes this sound. So that's how we know it's time for the next talk. And otherwise, I have no purpose being here. I want to introduce the next speakers. They're going to talk about optimizing user flows through login, and then I'm going to start my timer. Thunderous applause for the lightning talk, please.
Welcome to Lightning Talks. I'm super excited to be here today and talk to you about how to welcome your users to your Android app when they get a new phone. So why is this important? So if you think about the Android ecosystem, it runs on phones, right? And we all get a new phone every 2, maybe 3 years. And when we do this, we reinstall all of the apps we've installed. And we do this, and all of our users of our apps do this as well. You do a little bit of math, you figure out if you buy a new phone every 2 years, that means half of your users are going to get a new phone this year. And if you don't do anything at all with your application, you're going to give them a cold welcome when they come back. And you're going to show them an email and a password form that's going to be like they've never used your app before. You're completely disrupting their flow of using your app. What you want to do instead is offer them a warm welcome. You want to welcome them back to your application and create this continuous user experience that jumps from their old device to their new device. So you don't have any friction, you don't have any retention problems for these users that are switching devices and using your application. There's a couple of products you can use from Google that help you do this. So one of them is Google Sign-In. I think everyone knows what Google Sign-In is, right? It's a button you press and you log in. All right, so it's a button you press and you log in. It's amazing for this flow exactly because it's very simple to do that login. So it's good for your activation originally because it's easy to log into your app. But when they get a new phone, it's also good for reactivating these users because all they do is have to click a button. And on Android, you can even configure it so they don't even have to click the button on the new device. They'll automatically log in. Google Sign-In works on iOS, Android, as well as the web. So you can use it everywhere, and it's a great way to add federated login to your application. Another feature you can use on Android is Smart Lock for passwords. So Smart Lock is, well, it's a password manager. It's named quite well. So it stores usernames and passwords, or even federated credentials, up in the cloud when the user confirms that they would like to save the password after they log in. So they're going to do this on their old phone. They're going to save their password. And then when they get onto their new device, when they first come into your application, you're going to give them this warm welcome. You're going to say, I know who you are. Do you want to log in with that account you've already saved for this application? And it's just going to create that seamless experience and log that user into your application. So one of our partners, Netflix, who I believe is here today, actually, so Netflix used this, and they found that they had 20% fewer support requests. And so if you think about that, maybe every time a user contacts you to get a username and password fixed, there's probably 5 users that didn't, and they're just not going to come back to your application for months or even years at a time. They might just become a retention problem. They may never come back. So this is a fantastic way to improve your business metrics. And then Autofill is a new feature we launched in Android O. It works kind of like Smart Lock when it comes to usernames and passwords. So it's an autofill system, right? So it autofills text views exactly the way you'd think. And one of the most common text views to get autofilled is usernames and passwords. So the way this works is after they log into your application on their old device, they'll choose to save it to the autofill service. And that's going to go up to the same data store as Smart Lock. It's a secure data store for passwords. And then when they come back on their new device, it's just going to go ahead and autofill. So there's a couple things you can do to get your application ready for autofill. One of the biggest ones is set up a digital asset link that links your web and your Android app. So this is great because Autofill has pluggable password managers, but all of the password managers support this. And when they do that, what happens is the user can log in on the web, and if they're using the same password manager on their Android device, they're going to go ahead and get those credentials transferred. So they log in on the web, install your Android app, and the password's already saved. They get the seamless upgrade experience to your Android application. Another thing you have to do for autofill, well, you don't have to do it, but if you want the best experience for users, you should set up autofill hints. So you should tell the autofill service what the username, what the password field is. That way, the autofill service doesn't have to guess based on your IDs and maybe get it wrong, which is probably the worst experience you can give your users. And then the last thing we're going to talk about is auto backup. I'm going to hand it over to Jeremy.
Yeah, so auto backup is a great way to also provide continuity to your users. So even if your app syncs to the cloud, there's still usually device-specific settings that you can back up. And there's also, no user who's been using your app for a year wants to see a tutorial first thing when they launch your app when they're on a new phone. So auto backup works by when the phone's idle, we back up to the cloud. Your data is stored securely. You can have up to 25 megs. But if you go over that, backups will fail. On the new phone, when the user installs the app, it will restore the data before the app runs for the first time. And the user picks up where they left off without any friction or churn. You can also include and exclude specific files. So for example, you can exclude OAuth tokens or other things that shouldn't be backed up. And with all these tools, it's possible to provide continuity to your users and keep them engaged when they switch phones. We'll be back in the back if you want that.
Be around all day if you have any questions.
Thanks. Into the next topic, Kotlin plus watch faces, and go.
All right, hi, my name is Jeremy Walker. I'm a developer platform engineer here at Google. And I wanted to talk to you a little bit about how I use Kotlin to make watch face creation much easier on Wear OS. So watch faces are kind of hard right now. And you have to write about 600 plus lines of code. It's not like a nice app you do in Android or Wear OS where you can declare a lot of the UI in an XML format, you actually have to manually paint everything. And then you have to include a bunch of code just to make sure when you're in ambient mode, you're not hurting the battery life. So I was trying to think of ways to improve this. And last year at I/O, we announced official support for Kotlin. So I started thinking, how could I use Kotlin to make this easier? And I did convert the whole thing to Kotlin, which did reduce the code lines a lot. But I found something else with Kotlin that made it even more cool. And that was something called DSL. So what is Kotlin DSL? The best way to understand what a domain-specific language is to compare it to a regular programming language. So again, domain-specific language, that for me didn't really help me what it meant. But if you compare it to like a general programming language like Kotlin or Java, where you have a bunch of keywords, you have classes, methods, and you make a nice big app, the opposite on the other side is the DSL, which focuses on a specific task or domain. So it forgoes a lot of functionality and lets you just do that specific task. You've actually probably used external DSL and not even realized it. For example, SQL for manipulating databases, that's a DSL. So is regular expressions for manipulating strings. So they each have an independent syntax. They reduce a lot of the functionality. You don't need like methods or a class to make them work. You're not going to write a full-on application in them either, at least I hope not. And for SQL, the first keyword kind of indicates as a verb what you're going to do. Maybe you're going to select or you're going to update. The disadvantage here, as you probably know, is you have to put that as a string literal. So you have to pray and hope that you spelled everything right until runtime, and then maybe it fails, and you have to hack through it and figure out what's going on. So with Kotlin DSL, it actually extracts that out of the string, and it puts it right in your code. So you can have type checking, you can have code hints, and all that good stuff that comes with your IDE. So now that you kind of have an idea of what it is, I'd like to show you two structures really quick. And I use the latter, but there's one called creating one through chain method calls, and the other one is nesting of lambdas. So recognizing DSL is really subjective. So you know it when you see it. So let's see some. So this is Kotlin DSL for SQL. You could probably look at it, and if you know SQL, you can understand it right away. And it's all verbs like slice, and then I select all, and then I group by, then I order by, and then I limit. And this is all type checked. And you get code hinting so you don't spell anything wrong. And this is pretty great, and it's understandable. This is DSL. But the DSL for the watch face, which I really liked, was the nested lambda structure. So this is to create a watch face. You can see right away, create a watch face is the verb. But if you look at my structure, you don't know anything. You may not know anything about making a watch face, but you can probably understand what's going on right away. Analog watch face. OK, it's not digital, so it has arms. Colors, OK, I can figure that out. The dimensions for the hand, the hour hand, the minute hand, the second hand, OK, I understand that. Watch face background image. So that's all, it's very declarative, so you can kind of understand right away. And this is all type checked, and I get code hints and all that good stuff. And in the end, I get this nice little watch face with no work. Now, the 600 lines, they didn't all go away. I put them in a helper class and combined it with the more important class that interprets this DSL. But if you're making a watch face, you only need to know about the DSL. So what's next? This was kind of an experiment I did as a code lab, so check out the code lab. It'll only take you 15 minutes to make a new watch face. Just search for Kotlin watch face code lab. Geez, that's really long. Just search for Google Code Lab, and it's under the Wear OS, or search under Kotlin. You can see how to make a watch face, and you can see the code, or the source code for how I made the transition between DSL and interpreted it into a nice little watch face. But more importantly, hopefully now you're a little bit interested in DSL and say, hey, I could use this in one of my projects to make it a little bit better. Or you can go out and use something like the DSL for SQL. There's one for testing, and one that's more similar to mine. You can even do HTML in your Kotlin coding, type checked, which is kind of what I modeled mine after. So thank you for the talk, or letting me talk, and hopefully I've kind of got you a little bit interested in DSL. Thank you.
Well done. No gong. Next up, we have push notifications. And ready, set, go.
Thank you. Hi, everyone. I'm Amrit. I'm a developer advocate at Google. And today I want to talk about push notifications and how Indian developers are hacking to kind of get the delivery rates a little higher in the region. So let me talk about one of the stats about India. We have about 340 million plus smartphone users, and it's growing at a 16% year-on-year growth rate, which means that your apps have a great chance to acquire more users and have great business in the region. But along with this business, you have also comes with a lot of competition. So there's a greater need to kind of have a better engagement as well as delighting your users. And push notification is one of the mechanisms a lot of developers use in order to engage your users. When it comes to push notification delivery rates, some of these patterns in India actually affect the notification delivery rates. One of them is a user behavior. Until recently, data plans were very expensive for us in the region, and people tend to have the habit of turning off mobile data when they're not using internet. So when they go out of a Wi-Fi zone, they just turn their mobile data off. And that kind of changes the behavior of something like a time-to-live parameter for your push notification. If you have a really short one and the person has turned the data off during that period, your notification never gets delivered. Recently, we had new carriers who come in and have reduced the data cost drastically. And now this user behavior is slowly changing, but it hasn't changed enough for you to ignore this change. Secondly, we have a lot of devices with custom behavior or custom Android builds, where your notification, and because of battery optimization, they kill off these notification services. They sometimes force close apps, which avoid the app from ever getting the notification delivered to it. So that's another problem. Your time-to-live parameter, if you actually increase it by, say, from 4 to 8 hours, you see a drastic improvement in, or a large improvement in notification delivery, because you might end up overlapping with the Wi-Fi usage time. So things like that make it very interesting. Like in any other region, notification frequency also, the number of notifications that you send in to the users also affect. And people do get irritated and turn off notifications if you do it too many times. So using collapsible keys and things like that are very important here. Now, I want to talk about 3 design patterns that developers have actually tried out for various use cases to kind of improve notification delivery. One is bucketing of notification. This kind of gives you a better understanding of your user base and how each of these buckets actually work better for you. Let me explain that. The mechanism that they've developed here is that there's a periodic job that runs, refreshes the FCM token, sends it to the server, and when the server gets this data, it actually keeps a user FCM token mapping along with the recency of update. It will also take the timestamp of the update. Now, when you send out a campaign, what they would do is they would split it based on recency. Like, say, for example, you would send your push notifications in the first batch to all the tokens that were updated in the last, say, 7 days. Then the next batch would be to update it from 7 to 31 days, all the tokens that got updated in the last, from 7 to the 31 days, and third batch would be 31 and above. What this allows is that you can fine-tune each of these buckets, the parameters for each of these buckets, to improve notification delivery. You also have a better understanding of who your users, which users would get the notification and might react to your notification better. And because you have a lot of tokens which are not updated frequently, or the users never send that update cycle, you don't end up calculating that into your notification delivery and miscalculating the effectiveness of push notifications. The second one is basically where you have, again, a periodic job that comes in. It checks whether a notification was delivered to the device from the last run or not. If not, it'll go to a service, a REST service, pull the notification, and then display to the user. This is fairly simple to use, but you have to ensure that this does not excessively wake up the device. So this is not the most effective or efficient way of doing things, but still works for it. The last one I want to call out is data messages with a schedule. In a case where you want to send a message like, hey, there's a sale that's going to start at 12 o'clock, and you want to show the message at 12 o'clock for next 6 hours, you have 20% off on this device or on this service. Where instead of sending it on 12 o'clock and hoping that most of your users would receive it, what they would do is they would send this message maybe 2 days before with the last time to live, and as a data message. So the app would receive it. Then, based on the schedule that's within the data message, they would schedule a job to come up at the exactly right time and display the message to the user, which means at 12 o'clock, a lot more of your users will start getting that data.
That would be time's up.
Cool. Thank you.
All right. Thank you. On with generic system images.
Hello, everyone. My name is Hong Yin. I'm here to talk about GSI, the generic system images. GSI is, by definition, the purest form of Android framework that we can build from AOSP. By purest, we mean that it doesn't contain any device maker or carrier customization. You will want to ask, AOSP has been there for 10 years. Why does it become a thing right now? It is because GSI is the central piece in Treble compliance. So remember the project Treble? We took on the Android updatability problem with Treble about 2 years ago in the Oreo timeframe. We re-architected Android to have a clear boundary between the Android framework and the hardware-related vendor implementation. With this boundary clearly defined, we no longer need to update the vendor implementation with the Android framework. So this has greatly reduced the cost and time for device maker to update their Android framework. Now, to make sure that the boundary is not altered by device makers at will, we require every Treble certified device to pass a set of CTS and VTS tests with their Android framework replaced by GSI. So with all these powerful tools in place, about a year ago, we started to see the momentum of faster Android Pie adoption this year. So let's take a look at the Android beta program at Google I/O last year. Only Nexus and Pixel phones were available for you to try out Android Oreo. And fast forward 1 year later at Google I/O this year, it was the first time ever that we had non-Google phones to join the beta lineup. And it's not one, it's not two, it's 7 device makers joining us. So the progress was phenomenal. We know we are on the right track, and we will continue to push for it. Now, despite that the GSI is the central piece in Treble compliance, we feel that it has a lot more potential than that. So we set out a goal to make GSI be more accessible and useful, not just for device makers, but also for the general public, including app developers like you, and even consumers. An important first step toward that goal is to make GSI available in AOSP. So for this, we have published PyGSI in AOSP. So now you can download and build PyGSI today. We are also exploring ways to make future GSI available earlier than the release of next Android version. So you will be able to try out next Android version earlier over GSI. And at the same time, we can also get early feedback from you. So the benefit is mutual. So please stay tuned for our further announcement on this. Finally, we understand that trying out GSI can be cumbersome sometimes. We are looking into different ways to improve the process. Right now, we have an idea of trying out GSI without actually flashing GSI onto the device. But I'm not going into detail here. We do have a working early prototype at our demo booth. In addition to that, we also prepare a set of devices. They are all running on the same PyGSI. So please do check out our demos at the Android Platform Sandbox.
Thank you.
That's the end.
That is time.
Yep.
Perfect timing.
Thank you.
Excellent. Next up,
Nahid, connectivity.
connectivity. And ready, set, go.
All right. Hi, folks. My name is Nahid, and I'm a product manager on Android connectivity.
And I'm Ryan Hamilton, an engineer on the Chrome networking team.
Awesome. So let's start with the XKCD slide. How many of you have noticed this in past few years? Raise of hands. Where you thought that Wi-Fi is flaky and you are trying to turn off your Wi-Fi? The challenge here is that the only constant is change. Connectivity keeps changing underneath you, and your application trying to understand what's going on underneath is really complicated. And for creating a good experience, we need to hide these complexities from the user. We don't want users to go and turn off their Wi-Fi in order to use the app. It could be any app that you can think of that the user is using at a given point in time. So who should care? If you're building a user-facing application, maybe your app depends on mobility. Maybe it's Google Maps or something like that. Or you're building a gaming application or communication application. Anytime you know that you need to react really, really fast, irrespective of what's happening on the connectivity is critical, then you should, this is very, very important to make sure that you address it in your application. And one thing I would add here is the user drop-off rate when the delays are maybe 1 to 3 seconds or 3 to 10 seconds. It might vary between different markets. So for instance, if you're an emerging market like India, you might see more resilience to more delays. But if you're in somewhere like United States, if you go beyond 3 seconds, you will lose your user. So what I have here is a demo, and it's a Google Assistant demo. What we are doing is we are using this technology, and we'll talk about that a little bit later. But on the left-hand side, we have no optimization on the phone. On the right-hand side, there's an optimization, and what we are doing is we are doing a Google Assistant query, and user is walking out of the building. The phone is connected to Wi-Fi, and as the user walks out, the phone loses the connectivity. Let's see what happens. Trying to click. That's interesting.
Maybe we should.
OK. OK, in interest of time, this is what happens. The one on the left-hand side, it takes, oh, is it possible to play this? Awesome. OK, so we'll make a query. And what it's doing is direction to Oxford Circus. It's in London. And the one on the right, you see the response came back already. And the left one, it's still waiting and waiting and waiting. The right one is like, I don't have anything to do. I'm out. The left one is, finally. You know, this is a lot from reaction time perspective. And you want to have this resilience in your app that it can react really, really fast, irrespective of what's happening on the connectivity stack. So let's get out of here. Now it's a separate problem. Sorry. OK, so what it's using, what you need is you need a protocols that can handle this different mobility where your device is moving between the networks. And so that's where the Chronet and Quick comes into play, where it's the application layer and the protocols that you are using can handle this mobility. So I'll hand over to Ryan to talk about Chronet and Quick.
I'll try to do this quickly. We've taken the network stack that is inside of the Chrome web browser and made it available as a library for apps to use, and we call it Chronet. Chrome network, Chronet. Since it comes from Chrome, it's got all of the reliability and interoperability that you'd expect. It's already being used today by a variety of Google apps, Search, YouTube, Maps, and it's even available on iOS as well. Coming soon, it's going to be an option to pull from the Play Store, so you won't even need to bundle it in your app, and you can get the automatic updates and security and performance improvements. part of the coolness of Cronet is that it comes with support for Quick, which is a new transport we've implemented in user space on top of UDP. And it does some things that TCP can't. Quick is a modern transport. It provides some new features, some better performance. In particular, with quick connection migration, you can seamlessly switch back and forth between Wi-Fi and cellular. It has a bunch of awesome performance highlights. We release every 6 weeks. Comes with state-of-the-art security. And over to Nahid.
And the best part is that the platform optimizations are built in, so you don't have to do anything every time we do Android releases. We'll automatically make sure that it takes advantage of all the latest and greatest that Android platform has to offer. So you build it once and ship it. For any more questions, we have a booth outside. You can talk to us, and we'll be happy to help. Thank you.
Thank you.
Thanks. One last talk as an extra special bonus. This person gets 10 minutes because he needs to autofill.
Which is Chat's favorite topic, right?
Oh, absolutely.
Yeah.
Yes. Autofill all the time. Go.
So hi, everybody. Oh, sorry, where is, oops, back time. So my name is Felipe Leme. I'm a software engineer in the Android framework team, and I'm the technical lead of the Android Autofill framework with the topic of today's presentation. So our goal today is to give a quick introduction of what Android Autofill is and why it's important for you to optimize your apps for it. So the Android Autofill framework is a new feature that we introduced last year on Android Auto release. And the goal is to provide a safe and fast way for password managers to do their jobs. So basically, to use Autofill, you need to select an Autofill service, which could be a service that's provided by the OEM, like a Google Autofill or Samsung Pass. Or you can install a third-party apps like a password manager, like a LastPass, Dashlane, 1Password, InPass, and many others. Last time I checked, there is about 30 different apps on the Play Store that provides an Autofill service. And one key decision we made when we designed this API was that it should work out of the box with the existing apps. In other words, you as an app developer, you don't need to change our app to support Autofill, because if you don't do anything, most likely the password manager will figure out what to do for you. But just because you don't need to change it doesn't mean you shouldn't. After all, it's your app that's on the line, and you don't want to depend on the third-party app, which you don't have control over. So the rule of thumb, the main tip that I would like to give it is you should not rely on the Autofill service heuristics. Rather, you should provide your own tips, like you want to make sure that the password manager or the Autofill service do their job properly. And you can do that quickly or easily by just annotating your XML views. So the first thing you should do, you should make sure that you annotate what should be autofilled, and you do that using the Android autofill hints tag. So let's take a quick look on an example. Let's say you have the traditional username and password login screen. So if you don't do anything at all, if you don't annotate your apps for autofill, and your layout XML is using Android IDs like a username field and password fields, most likely it's going to work fine, because when the password manager see this view structure, they're going to be using some heuristics, and they're going to say, OK, there's a username substring here and a password here, so they will know this is username and password fields. Now, let's say you're a software house in Brazil, and you like to use names in Portuguese. I actually grew up in Brazil, and I know this is kind of common. So now my resource IDs are called Campo Usuário and Campo Senha, and this is totally valid from the Android point of view. So now the password manager, they will get this view structure, and they will know what these fields mean. So basically, they're not going to be providing the autofill data, and the user will have to manually type in the username and password, which is exactly the kind of problem they try to avoid with a password manager. So the solution for this problem, you simply annotate your views. So with the Android autofill hints, in the case of username, use username, and password, use password. And on Vue.java, we actually provide hints for the common fields, like username, password, credit card number, telephone number, etc. Now, there is also the other issue, which is you should also annotate what should not be autofilled, and you do that using the Android important for autofill tags. So just to see another real example, when I was developing this API last year, at one point I want to send an SMS to my friend, and then I got a pop-up with my own telephone number as the recipient of the SMS. That doesn't make sense, right? Because when you're composing an SMS or email or a spreadsheet editor, usually you want to type something dynamically. You don't want to use the predefined values that password manager has. So this was kind of annoying for me, because I knew the API, but it could be confused for a user that doesn't. So the solution for this case, you simply should disable autofill for your activity. And you can do that on the whole activity layer by annotating the root view with important for autofill equals no exclude descendants. So now, not only you don't risk the password manager provide the data where it doesn't make sense, but you also improve the performance because you're not triggering autofill at all. So these are, I would say, are my main tips. And let's say I convinced you to use these tags, and you are so excited to change your app that you're going to skip the rest of the presentation, the summit, go back to your laptop, and change your app. So now, don't do that, but if you do, how are you going to change, how are you going to test your changes? Remember, you need to select an autofill service to see what would be the data provided by the service. And your first impulse might say, OK, let me just choose whatever comes with my device, like Google Autofill or Samsung Pass, or maybe I'll install a third-party password manager. Well, if you do that, you could do that. But again, you're going to go back to that problem of relying on the password manager heuristics. In other words, maybe they will provide autofill data without your changes, so you're not going to really see what's going on if you make these changes. So my suggestion is to test using standard autofill service, and we provide some of them on the official samples that is hosted on GitHub. So basically, we provide a couple of autofill service implementations at project. One of them is called Basic Service, which is basically is a service that only understands autofill hints. So if you're using autofill hints on your app, when the user click on a field, you're going to see this pop up like this. Like we know because you said that this field is username, you see these username options. On the other hand, if you're not using these hints, then the autofill, the basic service wouldn't show anything. This is also a pretty simple service. It has like less than 200 lines of code. So if you're interested in understanding how an autofill service works, it's a good example as well. Now, we have another service that's quite the opposite. It's called debug service. So this one tries to fill anything. So if you don't use the autofill hints, they're still going to try to autofill based on your resource IDs. And this is useful to test what would happen if you're not tagging your views with imported for autofill equals no. So for example, back to my SMS app, you would see something like this. When you click on 2, I'm just make sure, OK. Let's just make sure I'm seeing, because I'm looking on the screen here. So basically, when you click on 2, you're going to see this pop up with some user autofill data, which is 2, which is just the name of the resource ID. So you could see how confused it would be for a user if they see something like that on their app. Now, the final tip I would like to give is you should also make sure that your app works when the autofill service requires authentication. So what that means? Well, most password managers, they don't return the user data right away because the data might be encrypted or might be locked somehow. So they're going to ask the user to authenticate. So the user might need to type a master password or maybe user fingerprint to unlock the data. And the way the framework works, we're going to be launching a new activity that belongs to this service on top of your app's stack. So the user is going to do the authentication, and when the user finishes, your activity resumes. So for most apps, this is not going to be a problem. But if your app is doing something weird on the activity resume, let's say you're reinvalidating, rebuilding the view hierarchy, or you're using some WebView to do some JavaScript code dynamically. So basically, you might break the autofill, as we're going to see in the next slides. So again, to test this, to make sure that your app works on this scenario, you need an autofill service that requires authentication. And the simplest way to do that is using the debug service. So when you launch the settings for the debug service, actually, first you need to enable autofill and select the service. So you can click on the button and select the debug service. You see the debug autofill service is one of the options. We provided that sample. Then you can select these authenticate response options. It's on the top. Now, when you go back to your app, when you trigger autofill, instead of getting the data unlocked, you're going to get this prompt to authenticate. So when the user taps this prompt, we launch an activity. In this case, it just asks for yes or no. So now when you click in yes, in this case, let's say that from this screenshot, I'm using a sample app where I'm explicitly recreating the view hierarchy on start. So basically, when I click yes, we return to our activity. But now from the framework point of view, all the data is different. So they don't know that they have the locked data for your username field because it's a different ID. So it's going to show the tap to authenticate response again. So when the user clicks there, it launches the authenticate and say, yes, sure, I want to authenticate. And then you go back, ask to authenticate again. So basically, the loop, the user is now on this groundhog loop where it never goes forward, and it's kind of frustrating. So the solution for this case is just want to make sure that you don't you create a view hierarchy on create. So now when the user taps to authenticate, we still launch the authenticate activity. The user say yes. Now when we go back, we show the unlock data, and when the user select the data, then we autofill, and everybody's going to be happy. So these are my main tips that I would like to give from this session. So basically, make sure you annotate your views for autofill, you test user standard services, and you make sure they work with the service authentication. So I have some links here. We have, if you go to the official autofill guides, we're explaining all these topics, and we have links for the autofill sample services as well. That also has all these apps I'm using for the autofill samples. So that's it. Thank you for coming, and I guess supposed to say that the QA will be outside on the speakers lab, and we have 25 seconds before chat comes to gong me out.
I'm here. Do you want to say anything else? Are you done?
No, we're done. Yes. Yeah. He works.
Awkward end. Thank you. I want to say thank you to everybody that played the game today.
Android Jetpack is a set of libraries and guidance for modern Android development. Now, there are 4 categories that make up Jetpack. This video is all about architecture. Here are the architecture component libraries. These libraries work great on their own, but they're also built with each other in mind and can fit together like puzzle pieces. The documentation contains a guide to app architecture, which shows one way that these puzzle pieces can combine to create a testable and maintainable app. This architecture revolves around the following principles: the separation of concerns, loose coupling, the observer pattern, and inversion of control. Okay, let's go ahead and start at the bottom. Room is a SQLite object mapping library. It uses annotations to generate boilerplate code for you. You declare your SQLite tables using entity objects. Entity objects are just simple objects with a few annotations. For example, I can take this class representing a user, and after I add a few annotations, it becomes a representation for this SQLite table schema. When defining the operations you perform on your database, you essentially write annotated SQL statements. This is where Room's object mapping capabilities come in. You can put entity objects directly into your Room database, or have your database return entities. No conversion or intermediates were needed. Compile time checking is also included, so if you mess up your SQLite queries, Room lets you know right away. Room also supports observable queries, including RxJava flowables, lists, optionals, and Guava classes, migration between schemas, and testing. Another fundamental part of any data layer is threading and background work. To make sense of background work in modern Android development, we've created the Guide to Background Processing, which includes this handy table. You'll notice that there's this new library here, Work Manager. The Work Manager library provides a unified API for deferrable, one-off, or recurring background tasks that need guaranteed execution. The background tasks are work request objects. With Work Manager, you can build a complex processing and upload flow like this using chains of work requests. As part of the chain, you can define the output of one work request as the input of another work request. You can also set conditions on when the work request should run. Work Manager then performs the work requests in the order that you specified, while also taking care of compatibility issues and best practices for battery and system health. As part of guaranteed execution, Work Manager handles continuing your work across device restarts and if your process is force stopped. Finally, Work Manager can return the state of the work request so that you can represent this state in your UI. Okay, let's go ahead and take a look at the lifecycle libraries. The classes in this library help with Android lifecycle management, specifically with avoiding memory leaks when updating your app's UI. Here is one example. Have you ever rotated a device and had the app crash or lose data? Well, adding a view model can help fix this. Unlike activity objects, a view model object isn't destroyed when the device configuration changes, such as when the screen is rotated. This property of view model makes it a good, stable place to put all of your UI data. The view model usually contains another lifecycle object, live data. Live data is built for easy communication between the UI and deeper layers of your app's architecture. Live data is an observable data holder for data that is meant to be shown on screen. Basically, it'll wrap around an object, like this user object over here, and allow the UI to automatically update whenever properties of the user object change. Live data is also lifecycle aware. This means a live data object only tells the UI to update if the UI's lifecycle state is in the correct state. For example, if your activity is not on screen, then the live data will not trigger updates. Also, if the activity gets destroyed, then this observation connection is cleaned up for you automatically. So, as your data changes, you never accidentally trigger an activity or fragment that is off-screen or destroyed to redraw itself. The lifecycle libraries include other powerful features. For example, live data supports transformations. As mentioned before, Room can return live data objects, which allows your UI to observe objects in the database. View models and live data also now support data binding. You can bind these classes to an element in your app's XML layout definition. That lets you get rid of all of this boilerplate code. The Lifecycles library also contains classes and interfaces for querying and observing UI lifecycle states. The Paging library integrates directly with Room and live data. Now, there's a common situation where you have a lot of data that you want to load in small, manageable chunks. The Paging library is built exactly for this use case, and it avoids tricky SQLite cursor performance issues. The library offers the following features. It allows you to define the data sources that you're going to use, be it data from the network, a database, or another data source of your choice. It works out of the box with Room and Recycler View. It supports lists of any size, including lists of infinite length. It leverages live data to update your UI as more data is loaded, and it has support for RxJava. Finally, there's the Navigation library. The Navigation library and tooling simplify implementation of complex but common navigation requirements and help you visualize your app's navigation graph. Now, for trivial apps, navigation might seem simple, but when you add things like fragment transactions, the need to implement proper back and up behavior, support deep linking, add a bottom bar, and include animations between screens, let's just say that things get a little bit messy. The Navigation library simplifies all of this. Now, the basic building blocks for navigation are called destinations. Destinations are specific screens you can go to. There's out-of-the-box support for fragments and activities as destinations, but you can also make your own. The new Guide to Navigation encourages you to have activities as entry points for your app. They also contain global navigation, such as this bottom nav. Now, in comparison, fragments will be the actual destination-specific layouts. This UI structure allows you to share an activity view model between all of the fragments associated with that activity. As the user navigates from fragment to fragment, you don't need to serialize that shared data. The new navigation editor in Android Studio enables you to quickly specify destinations and visualize your app's navigation architecture. The connections here show the possible navigation paths between each destination. This generates XML, which you can edit by hand. The library uses this new navigation graph resource and a new nav controller object to move your user through your app. Now, this is just scratching the surface of the proverbial iceberg that is the architecture components and Jetpack. Hopefully, some or maybe all of these libraries piqued your interest. To learn more, we've got dev bytes for all of the stable components. We also have code labs for each component, and of course, thorough documentation. Now, if you find yourself left with questions, we've also got Stack Overflow tags and an issue tracker. Or, you can yell at me on Twitter. Actually, don't yell at me on Twitter. Happy coding!
My name is Adobe Frank, and I'm a Google Certified Associate Android Developer. I started mobile development when I left school, and I was based in Abuja. That was where I was raised, that was where my parents lived. My husband knew that I wanted to further my education and my career. But over the years, things had been really hard, so we hadn't had that opportunity. So the next thing was to do certification courses to boost my resume, basically make me more hireable. I had a job that required me to move to Lagos for 6 months. I was the only female until a team from Andela came to join the project. I think that was the first time I had even heard of the scholarship program to get the Google Android certification. When I got the email that I had qualified, I called my husband. Yes, we have this scholarship. I was struggling for time. I was already working a contract job in Lagos. I would watch these videos on my way to work or on my way back. So I would be with my headphones and with my phone all the time. When I just finished the certification, I actually got a call for a job offer based in Abuja. This is something that will make me earn more than 10 times of the salary that I was earning before. 10 times, I kid you not. The interview process was something that would normally take like weeks, was like a couple of days. Oh, you are Android certified, great, awesome.
It was an amazing moment when she got the seal. So and the pay began to pick some bills, rent, you got to help us to fix the cars. She's been amazing, she's been supportive, she's helped me.
So now I'm like working from my house, and I can actually call myself a developer, like not like, oh, in my community I am awesome. In the world, I am okay. Must not be awesome. We are trying to be awesome, but okay.
Good afternoon. Thanks for coming. My name is Phil. I'm here with Casey and Qasid. And we want to talk to you about making accessibility easy on Android. Thanks. So first, a bit about what accessibility does. And ultimately, a lot of engineering ends up being about assumptions, right? We find that usually when we find that when we've made an assumption, we eventually discover it when we realize it's not right. And that happens a lot with accessibility. It's really easy to make assumptions about what people, particularly people with disabilities, can and can't do. If you meet somebody who uses a power wheelchair, you might make an assumption that they probably don't play soccer. And this, on the face of it, might sound like a pretty plausible assumption. But then you haven't seen my son's power soccer team. There was a World Cup of power wheelchair soccer. So whatever, if you meet somebody who's blind, I've heard people who are, for example, using photo carousels, thinking, well, maybe blind people wouldn't be interested in keeping track of photos. No, we now have technology to let blind people take pictures of things, and they're very interested, it turns out, in sharing them with people. And then there's sort of the simplest one, which is making the assumption that somebody who's not able to move their mouth can't speak. But of course, Stephen Hawking demonstrated that that assumption is wrong long, long ago, and thank goodness he did. So on Android, we make a lot of assumptions it seems like a lot of assumptions sort of built into our devices. You take a touchscreen device, touch screen, you might assume that all of the users are able to touch the device, or that they can all see what's on the screen. But of course, that turns out not to be true. And so these assumptions, we have to learn to kind of question them. So otherwise, they become obstacles. And so a lot of what accessibility really is about helping people with disabilities overcome obstacles. And we want to really, the first thing is just to make sure that the obstacles we're helping them overcome are the ones inherent in their disability, not the ones that we've created by making additional assumptions about what they're interested in, what they're actually able to do. So the way Android does accessibility is really, it depends on the entire ecosystem. So we who work directly on Android, we build a lot of the core of it, but we really depend on the entire ecosystem to make this work. So the accessibility framework is going to handle a lot of low-level features, things like magnification. As a developer, you're not going to build a magnification experience into your app in order to help, so that if we try to do that into every single app on Android, we're going to end up with just a nightmare experience. And also, it's something that's really best handled down close to the graphics level. We want to just magnify things. Accessibility developers, people who work on accessibility services like TalkBack, Switch Access, Voice Access, Select to Speak, they build these plugin services, and the idea is that they will generally have a particular type of user in mind, and they'll go through and really understand what those users need, what their challenges are, and try to build something that works for them. But they, of course, can't do everything on their own. They need to get information from, like if somebody is blind, you need to be able to speak what's on the screen. We need to find that out from the apps, what's actually going on in the UI, and that's where we really need the help of the entire ecosystem and all developers. So our general model is we have these plugin services. So in this case, Switch Access, Voice Access, and Braille. And they're able to query an API for the accessibility service to find out, like, tell me what windows are on the screen. Tell me what the views are inside these windows. What text is where. What actions are available on each view. And then they can present this to the user in whatever way they need to. If the user's not able to touch the screen, do you want to activate this control, that control? Do you want to perform this gesture? And do it on their behalf. But we really need the apps to provide the right semantics to do that. We want to try and make this as simple as possible. So just a few things to kind of keep in mind. One is just to make sure that the information that you're presenting to all your users is as visible as possible. So luminance contrast ends up being kind of the most important single thing that you can do in that regard, just to make sure that you're not using gray on slightly lighter gray to convey information. And sometimes that can end up looking kind of cool, but it becomes very difficult for some people to use. The second thing is to just prefer controls to be big and simple. It's sometimes a temptation to cram a whole bunch of stuff into a small area to get as many options as possible for users. And often just trying to figure out what is really important for your users can simplify things for everybody and also make it possible for somebody who perhaps doesn't have perfect dexterity to use it. And one thing is we have sort of a general 48 by 48 density independent pixels as sort of a guideline that we throw out there just to kind of have a uniform standard throughout the ecosystem. And that can be set with just like a min height, min width thing. And the other is to label stuff. So if you're conveying information visually, particularly what a button, if there's a button that just has an icon on it, just to provide a label. And these labels should be concise and precise so that users who are not able to see the screen can find out what they do. Sometimes people ask, when in my project should I consider accessibility? So the three-word answer is early and often. The slightly longer answer is, in each of these different phases of your project, there's sort of something you can do. So in design, generally the things that I just already mentioned of keeping contrast, control size, labels, that will get you a long way if you're using kind of standard UI patterns. But the more innovation you're doing on your user interface, the further away you're going to get from sort of the stuff we built into the Android framework. And at that point, it's really helpful if you can start thinking more broadly about how the full range of users who are going to use your project, your product. So the more gesture-type things that you're doing, you want to make sure that you're taking into account how people are going to interact with that if they perhaps can't perform that gesture. During development, we have a series of APIs. Costa's going to present some of those. And for testing, we have a number of testing tools to kind of help make sure that, as much as possible, we can automate the process of making sure you're handling these things correctly. So I just explained a whole bunch of stuff about all the complexities of users and all these different things you can do. So you could be forgiven for wondering why we said making accessibility easy. I did say making, not that we already made. But in general, what we want is we really want this to be easy. I think we want that to be, we want to make sure that we're doing that. And if we're not, please let us know. But if you're using standard components in standard ways, it really should be as simple as what I've already said, that you should just be having to label things. The questions that you need to answer should not be complicated questions about how is a particular type of user going to use your project. To be something like, what does this control do? But as you evolve in more non-standard ways, it is going to get less easy. But what we want is to make sure that the sort of incremental work that you do for accessibility sort of grows more slowly than the work you need to do to serve whatever users you have in mind to begin with. And now Costa's going to talk a bit about sort of a way to think about the development process for folks with disabilities.
Hey guys, my name is Qasid. I work for Phil on the Android accessibility team. So let's get right into it. Now, if you really think about it, there are two ways that your user can interact with your application, right? The first is consuming information. Now, this can be content that your user wants, or it can be indications on how to use your UI. And the way we consume information varies dramatically from user to user. So for example, I consume information by looking at what's on screen and consuming and processing it in that way. A talkback user, on the other hand, will hear a description of what's on screen from the device's speech synthesizer, right? Now, once a user has consumed and understood that information, and they've combined it with information from the real world, they can then act on your application to make it do things. And just like consuming information, this varies dramatically from user to user and from circumstance to circumstance. Now, these actions can be something like a tap, a swipe, a scroll. It can be speaking into a device. Some Switch users even drive the whole device with a single button. Now, once we combine these two modes of interaction, we see this cycle of action and information, right? And we can see that if any part of this is subtly broken for a user, our applications become fundamentally useless. So our goal becomes, how do we make sure that this is complete for every single user? Now, that seems like a daunting task, because like we've mentioned before, the ways that the users interact with our devices actually varies quite a lot. And trying to understand those users is quite a complicated task. But if you don't try to do anything too non-standard, and you trust us and you use our APIs, then this is actually a pretty easy task. So I'm going to show you some trivial things you can do, which are fundamental, and also push your accessibility to be much better than it otherwise would have been. Let's start in the ways that we break consumption of information. Now, for the purpose of this, I've created this nice little search application, a novel idea. And the way that I'm indicating that this is a search UI is by that magnifying glass on that little line. Now, right away, you're going to notice something. That's a very light shade of gray on a very slightly lighter shade of gray. And that's going to be difficult for people who, that's going to be difficult for a lot of people to see, because that's a very low contrast ratio. It can be frustrating and downright impossible for others. So what we should do is we should darken it up. And just like that, many more people are able to use our application. The goal here is make sure all of your information is visible in terms of size and contrast. And if you want concrete guidelines on this, you can go to the material website, and we can give you contrast ratios in different circumstances, and also hard numbers in terms of size, like the 48 by 48. Now, that was kind of straightforward, but there are clearly some dramatic variations in how we consume information. And for those situations, what we want you to do is we want you to fill in the blanks for our frameworks. What I mean by that is our framework can infer a lot from your view hierarchy from the code that you've already written, but there's some situations where we need your help. Let me show you. Let's just say that I'm a TalkBack user, and I'm placing my finger on screen to hear a description of whatever is under my finger. And I place my finger on the magnify icon. Now, I want to hear what that is. But unfortunately, there's no way for our frameworks to figure out what that means, because there is no text associated with that. I mean, it's essentially an arrangement of pixels on screen. So you guys have to fill in the blanks as app developers. And you can do that by adding a label. So in this case, I decided to label it search. Make sure you keep your labels concise and to the point. If it's something that indicates an action, then make it a simple action verb. This is actually pretty easy. In this situation, all you do is you set the content description. Make sure your string is localized, because it's a user-facing string, and accessibility users don't only exist in America. Now that our user can generally understand what's happening on screen, let's make sure we allow them to act on our device appropriately, or act on our application appropriately. So I decided to add a new feature. It's a clear text button, so you can easily, instead of having a backspace, you can easily reset and start typing again. But that's a really tiny button. You know, I'm going to have trouble tapping that, and someone who has some sort of fine motor disability is going to have a lot more trouble typing that. It might just be impossible for them. Let's make it bigger. And now, again, this works for many more users. Like Phil mentioned earlier, make sure your controls are simple and they're large. So I decided to add another feature. I decided to add a history feature. Here, you can tap any of the queries and see the results of the query again. Now, if you end up swiping on any of these items, you'll end up seeing a trash icon indicating that this item can be removed from history. And if you continue swiping, that item will be removed from history. So this is great and all, but this is a pretty custom-built gesture overloaded onto an item. And it's going to be hard for our frameworks to detect. So again, you guys are going to have to fill in the blanks for our frameworks and for accessibility users. Now, you can do that by adding an action or an accessibility action. And all you have to do here is specify a user-facing label or description of that action, again, a simple verb, and the bit of code that should be executed when this action is performed. Currently, you can do that with the Accessibility Action API, but we are actually adding something to the AndroidX library, which allows you to do this in a single line call with a lambda and a string passed in. So I've shown you a way of thinking about accessibility issues and how to address them, but you still need to know how to find these issues and how to verify that you've actually fixed them. This is where Casey comes in. Casey?
Thanks, Qasid. I'm Casey Burkhart. I'm a software engineer on Google's accessibility engineering team, and I lead the development of accessibility testing tools for Android. So as Qasid had pointed out, there are many common accessibility issues that actually fixes are fairly straightforward from the development side and can really improve the accessibility of your app. A big question, though, is how do we go about finding those issues? And there are 3 types of accessibility testing today that I'd like to cover. There's automated testing, use of automated tools, manual testing, where you use Android's accessibility services yourself to understand the user's experience, and finally, user testing, where you actually bring in users with various disabilities and truly get their feedback and understand their experience using your application. My section of the talk focuses mainly on automation, because right now we see that as one big area where we can make vast improvements across the ecosystem if we have some developers' cooperation using these tools. So automated accessibility testing, until several years ago on Android, didn't really exist. In around 2015, we launched a project known as Android's Accessibility Test Framework, which is an Android and Java library that essentially houses a lot of detection logic for the more common accessibility issues that we can identify within an app's UI in sort of a rule-based fashion. This is an open source project, so you can go and find it on GitHub. And essentially what it's aiming to do is look at your app's UI at runtime and find some more of the automatable mechanical aspects of accessibility that we see day to day that affect users the most. So we can find a lot of the common issues that Kas had discussed. So we can tell you if you have a control within your UI that is missing a label for a screen reader. We can identify low contrast text and images. We can tell you if you've got clickable items within a UI that fail to meet our minimums for touch target guidelines. And we also identify a number of various other implementation-specific issues. And the core testing library, ATF, is sort of growing constantly to find more new and interesting issues. We've taken this library and we've integrated it with common developer endpoints, essentially tools that you'll use commonly throughout the development lifecycle and you can leverage throughout your project. I want to talk through some of those integrations today and how you can use them and get started with them quickly. So first and foremost, we've got integrations with two test frameworks that are pretty commonly used throughout unit and UI tests on Android apps. The first is Espresso and Roboelectric. So essentially, the idea with these integrations of ATF is they will piggyback on top of your existing tests. So you have a test that runs, loads some UI from your application, interacts with that UI, and asserts some state. During the interaction phase of your test, if you've enabled our integrations with Espresso or Roboelectric, we'll actually evaluate the UI at the time that it's interacted with. So if we identify an accessibility issue that we believe will affect a user with a disability's ability to interact with your application, we will fail your existing test. So if you already have strong test coverage with either Roboelectric or Espresso, enabling ATF's integration with that test framework might be a great way to get a decent amount of coverage for automation in terms of accessibility testing throughout your app. A few other points to note here. Each framework offers what's known as an accessibility validator. And this is an object that you can use to essentially configure ATF's behavior inside of your tests. So you can configure ATF, for example, to not fail your test and just log something if we've run into an issue. You can set up ATF to crawl from the root of your view hierarchy whenever you perform an action, rather than just evaluating the item that was interacted with. It's a great way to get some additional coverage. And you can even use Accessibility Validator to set a whitelist. So if you want to turn on accessibility tests within your Roboelectric or Espresso tests, you can do so, maintain sort of a green pre-submit, and burn through issues that you know about by creating and registering one of these whitelists for known issues. So specifically inside how you leverage these between Espresso and Roboelectric, in Espresso you're going to essentially call accessibility checks.enable from within your tests setup. This is going to essentially trigger our global assertion to run whenever you use a view action within an Espresso test. So in this case, the view action is run. We'll perform an evaluation on the view that was interacted with and its subtree. Accessibility validator is actually returned by the call to accessibility checks.enable. So if you need to further customize ATF's behavior, you can do so from the object returned from that call. Within Roboelectric, it's slightly different. So instead of calling accessibility checks.enable, accessibility checks is an annotation, and you'll annotate your test method or class that you'd like to enable accessibility checking within. And it relies on you using shadowview.clickonAll to actually interact with elements in your UI through your Roboelectric tests. So avoid the temptation to use view, perform click directly. The accessibility validator functionality is available in Roboelectric through a different class that mirrors the same API. You can just look for accessibility util and make static calls there to configure ATF's behavior. So in addition to integrations with these automated test frameworks, we've built a separate standalone tool known as Accessibility Scanner. This is a direct integration of ATF, but Accessibility Scanner sort of acts as a front end for the library. It will evaluate the foreground UI of your application at runtime on an actual Android device. And the way it works is essentially you install Accessibility Scanner, you turn it on, it will add a floating button globally to the device's screen. You'll open up your application, navigate to the UI that you'd like to evaluate, and just tap the button. And what you see is essentially a report that describes the ways in which you can improve that UI for accessibility. And again, these will mirror the same types of issues that ATF and Espresso and Roboelectric can identify as well. It's very easy to take these reports from Accessibility Scanner and share them with your team. You can currently export to email or Drive. And it doesn't really require technical skills. You don't have to have a debug version of your application or a user debug device. You don't need to do anything special to set this up. It works on any app on any Android device running Marshmallow or later. And really, you don't even have to have a lot of experience related to accessibility. Each issue that Accessibility Scanner can identify comes with extensive documentation that gives you background on how that issue might affect users and how to think about that issue during the design, development, and test phases of your project. So please do download Accessibility Scanner. It's something I highly recommend we use when we build UI. g.co/accessibility scanner will take you to the Play Store page. Finally, one last integration I'd like to cover today, and this is a new one. We've launched it a few months ago. It's an integration of our accessibility testing framework and the Play Store Developer Console's pre-launch report. For those of you who haven't used pre-launch report yet, it is a great tool to sort of get a sanity check during the launch process, the release process, for an APK to the Play Store, either on an open or a closed channel. Essentially, the way it works is you upload an APK. Pre-launch report will take that APK, instrument it, and push it to a number of different physical devices in a lab. And we'll crawl your app essentially on these different devices and generate reports that include findings about performance, security, and now accessibility as well. So ATF is running alongside pre-launch report as it's crawling your application, and it's generating reports at each stage in the crawl. And it's taking all of the results and sort of deduplicating them. So if you'd like to check this out, it's available now in Play Store Developer Console under Release Management. And you should be able to see accessibility results for any APK that you've uploaded to the store since fairly early in July. So please do check that out. And here's what it looks like, just to give you an idea. Here, the main entry point for an APK will show you all different categories of issues that we've identified. It will show you clusters of issues. You can click on any one of those, and it will show you more details about the specific problem. So in this case, we're pointing out an issue relating to touch target size. And in the column on the left, you see many different examples of that same deduplicated issue across different crawls of your application that pre-launch report has performed. You have access to the same additional documentation here as well, too. So if you're not familiar with a particular issue, the Learn More link will give you the details you need to resolve it, regardless of what stage your project is currently in. So I want to wrap up by talking about an accessibility testing strategy. We talked a lot about automation, but we didn't go into too much detail on the other two, manual testing and user testing. And these are equally important. Automation is great because it helps you find issues very quickly early in the development cycle, especially if you have good test coverage with our automated tools. So essentially, think about automation as a way to catch very common issues quickly, but not as a way to guarantee that your app or your UI is fully accessible. To really understand your user's experience, to get that awareness of how your UI is actually performing with an accessibility service, we really highly recommend you go and actually turn on TalkBack, turn on Switch Access, try them out, learn how to use them, and gain a true understanding of your user's experience. The way I like to describe it is automation is capable of finding a missing label for a screen reader. But we can't really tell you if your labels make sense. So really only by understanding, putting yourself in the user's shoes and understanding their experience, or asking users directly about their experience, only then can you truly understand how accessible your UI is for users with various different disabilities. And we have found at Google, both looking at our first-party and third-party applications, the most successful, the most highly accessible apps that we see day to day are the apps that combine multiple accessibility testing strategies. So those that leverage automation during pre-submit or continuous integration, but also have a regular process for manual accessibility testing or bringing users in and understanding their perspective on the accessibility of an application. So these are all things to consider. With that, I'll hand it back to Qasid, who's going to talk to us more about some of the newer APIs for expressing app semantics.
Hey guys, I'm back. So let's just say that you've adopted the APIs that I've talked about earlier, and you've adopted the testing that Casey has suggested. And at this point, you've got a pretty good foundation of accessibility in your application. But the more you're testing, the more you realize that there's some holes in your experience. And that's breaking that cycle of interaction that I mentioned earlier. So we've been adding new APIs and new things to make it so these holes get plugged. So the first things first is clickable spans, those little clickable bits of text. Before API 26, non-URL spans were fundamentally inaccessible. And developers had to write a bunch of hacky workarounds to make these things work. That's now changed. In addition to that, in the latest alpha of the AndroidX library, we've added API to make this work all the way back to API 19. So you can look out for that too. Secondly, there's some views that, as far as the user is concerned, act and behave like Windows. They have their own special content, their own lifecycle, so on and so forth. And we call those accessibility panes. Now, you as a developer need to inform our frameworks to present these a little bit differently to the user. And the way you do that is by passing a non-null string to set accessibility pane title on the view. And again, this is a user-facing string, so make sure it's concise and it's localized. This is available in API 28, but we've also added this API to view compat in the latest AndroidX alpha, and that'll work all the way back to API 19. And finally, there are headings. These section titles are used by talkback users, for example, to navigate through sections quickly and easily. And the way you specify that is exactly what you'd probably expect. Pass in a Boolean to set accessibility heading on a view. This is also available in 28, and we added this to the latest alpha of the AndroidX library. That'll work all the way back to 19. Either way, thank you for your time. Now it's back to Phil.
All right, so sort of circling back to the title of this, which was making accessibility easy. We really want this to be easy. It's the only way that that users with disabilities are really going to be able to access the ecosystem. Because occasionally we'll encounter somebody who's really willing to do the extra mile, really dig into their app and sort out all of the issues for accessibility. And that's great, but not every developer can possibly do that. And so we need to make this as easy as possible so that everyone can kind of build this into their workflow in a really natural way. And so certainly to get the basics, we want it to be straightforward. So if you've got reasonable contrast to make the information visible to everyone, you've got simple big controls, you're using labels, we really want that to kind of get you almost all the way. And then some of these other APIs, like Qasid was just describing, should be able to handle some of these more specialized situations. Like if you've got a full screen fragment transition, you can use the pane title to make sure that gets handled the same way a window transition would. Saying that we want it to be easy, it means if it's hard, we've messed up. And we should fix that. We found some developers will well, the framework seems to be coming up short here, so I'm going to engineer a sort of a workaround to kind of get around the problems with the framework. Honestly, please don't do that. Let us fix it, because we can fix it at scale, and only we can. It needs to be fixed inside Android. If you find it in AndroidX, if you want to fix it, by all means, upload it to AndroidX, and we're happy to accept fixes. But we want it fixed centrally so that we can get a consistent experience throughout the whole ecosystem. If you are engineering some super custom solution, you can think, is an engineer working at a different company going to actually do this work? And if the answer is no, then there's probably something wrong. And so please reach out if we're messing this up. You can file bugs on AOSP. You can ask questions on Stack Overflow. But we'd much prefer we really prefer to get the feedback that something is difficult so we can try to find an elegant solution that everyone can use. We want some of the things that Kasa just presented before he did that work. The effort required to do some of these things really required like learning a new API surface. And we really wanted to condense everything we could down to like one line. And so we were trying to present solutions that really are like, if you've got this thing, here's one line of code, it's all you need. If you get to something that seems like it should be one line of code and it's not, let us know. And another place to go just for other resources is g.co, Android accessibility. There's a link here to the developer.android.com for accessibility testing, the link to get to the accessibility scanner, and also the test framework project that Casey described. That's available open source on GitHub if you're interested to look at that. So really appreciate your time, and we'd be very happy, especially if you've got feedback for us about things that should be easier than they are. We're going to also be out at the office hours for a while this afternoon. We'd really love to talk to you. So thanks a lot for coming and for your efforts in helping to make a consistent ecosystem of very accessible apps. Thanks.
Everyone, the next session will begin in 10 minutes.
Hello, everyone. So today at the keynote, you probably heard that we are unifying the developer experience for instant apps and Android app bundles. And so my colleague Ben and I are going to talk to you a little bit about how that works from the developer perspective. So instant apps, it's a technology that we introduced a little over 2 years ago at Google I/O. And it lets you give your users a native Android app experience without them having to explicitly go and install your app from the Play Store. Now, how that works is you split up your app into smaller pieces called features. And the user can reach those via a link, a URL, and also via other means, as we'll see later in this presentation. Now, to get your app small enough and to be able to launch it instantly, Instant Apps for the first time used a technology that we introduced in Android 5 Lollipop that's called split APKs. Now, with configuration split APKs, Play Store was able to deliver the smallest, most optimized version of your app to a user's device. Now, in order to do that, the build system, the Gradle Android build system that you have, that you build your apps with, built all of those split APKs locally, bundled them in a zip file called an instant bundle, and then you upload that to the Play Store, so that Play Store can choose from the set of APKs and deliver them to devices. Now, to do that, the developer had to do some significant refactoring in your apps. So the project structure of an instant app, as it looked 1 year ago, looked probably something like this. First of all, you had to take all of your base application code and move it from the application module to a base feature. Then you had to split your app into feature modules containing the various features in your app, or normally we would call them screens or activities. And then you had these two almost empty dummy modules, application and instant app, for building the artifact that we need. So the APK for application, that would be the installed application that you used to have. And then the instant app zip bundle that would contain all the split APKs that you upload to a separate track in the Play Store. Now, this was not ideal. As I said, it required significant work from you. Your project no longer looked simple. At the same time, this year, we introduced a new publishing format for Android apps called the Android App Bundle, or AAB. Now, this format preserves some more information about what's happening in your project. It contains some metadata about targeting of the resources, native libraries, and so on that are in your project. But it also actually retains some of the module information about a new type of module called dynamic feature that's in your project. Now, I called it a publishing format because you use it to upload this whole big bundle telling the Play Store everything about your app to play. And then, together with Google Play Dynamic Delivery, we are able to serve an optimized set of split APKs to users' devices. Now, in order to do that, there's one big difference. Because it happens on the server side, on the Play Store, we need to be able to re-sign your app. That's why if you use an Android app bundle, you have to enable app signing by Google Play. Now, that's a good thing. Actually, if you let us store your key for you, it is safer, it's more secure. But there's also another benefit. Thanks to the fact that we can transform your APKs and make them more optimized, as we develop more optimizations on the Play Store side, over time, what we deliver to users' devices can be even more optimized, as we just announced with uncompressed libraries. And so it will make sense to move instant apps to this new model. Why build all the APKs locally and then not be able to optimize them further on the Play Store? What if we could use the new app bundle format to deliver an instant app experience to our users? So let me tell you how to go back to that simpler, better project structure for your instant apps. So if you've ever done that whole dance to move modules around and move your code to a base feature and so on, we literally have to go back to that simple project you use as you would build your APK. So first of all, we no longer need the instant app plugin. Everything that we need is baked into the application plugin that can now build bundles. And so we don't need the base feature anymore. Instead, we can move our code back to the application. We'll be using that to build our unified bundle artifact. And so, again, with feature modules, we now replace them with dynamic features that work in the app bundle world. So ultimately, we want something simple. You can have your application module with any additional library modules that you need. Optionally, we have dynamic features that can be downloaded on demand, adding functionality to your app at runtime. And we have this single piece of metadata that tells the Play Store that this bundle is instant app enabled. So that would be great if you could upload that one artifact to the Play Store and have it published both on the installed and instant track. And that's exactly what we're aiming for. Now, there's one caveat. We are currently testing that with our partners, but you might not actually be able to upload this single artifact to the Play Store just yet. That's why, if you want to try it right now, I suggest you create 2 product variants in this simple project structure still. And in one of the variants, simply enable the metadata with enabling the instant app for your bundle, and use the other variant to build a bundle without that entry in the manifest. It's still simple enough, still one project, one app, one code base. Just for the time being, you might have to do that in order to upload to the Play Store. By the way, there's another whitelist. If you want to use dynamic features in order to let your users download them on demand as they run your app, this is also under a whitelist for developers who want to test that. You can apply online. However, you are currently not able to publish your app to the production track if you have more than one module. OK, so how to try it yourself right now? First thing you need to do is use the new Android Studio 3.3 that's currently on the beta channel. And if you're creating a project from scratch, you can simply select this checkbox. We'll create the modules with the necessary metadata already in there. So that's how it looks like in your base manifest. You instant enable it, and you're good to go. If your app is compliant with all the other instant app restrictions, such as file size, which Ben will talk about later, now you have a chance to publish an instant enabled bundle already. Now, if you already have a project which you're using to build an app bundle, you can also use the new module wizard to add a new instant dynamic feature module. This will also, if you add one of these, this will also instant enable your base module if you haven't done so. Now, all that's left is build an app bundle, either through Gradle, so the bundle release command instead of assemble release, or through the wizard and the UI. By the way, if you're using our Android Dev Summit app right here at this conference, it's been built exactly as an instant enable app bundle. So we published that to through our channels on the Play Store. What you're using right now is exactly what I'm talking about. And it's been great. It's greatly simplified what we had to do in order to have that working. Now let me invite on stage Ben, who will tell you a little bit about best practices for modularizing and discovery of your app. Ben?
Thank you.
Round of applause, please.
Thank you very much. So yeah, let me talk a bit about discoverability of your instant apps. Basically, one of them you already saw, which is the try now functionality. I'll talk a little bit more about this. So try now basically is a second button that you get on the Play Store, which allows your users to download and run the app straight from the Play Store without having to permanently install it on the device. That's a great experience that you can easily see how it worked. You can go to the Play Store now and check it out for the Android Dev Summit app. And your users can launch it directly from the landing page. It's quite cool. And if you don't have a URL associated with your app, that works as well. So you don't have the restrictions that your app has to map to URLs anymore. How do you do that? That's basically it. I think that everybody has this somewhere in their application. It's the main launcher. And if you don't have to do anything else than add the instant metadata that you already Wojciech showed you earlier. So there's nothing else that you have to do in order to be eligible for the try now experience. But what if you want to have your app available with a URL mapping? That allows you basically to access your app through any URL that you have associated with your app. The first thing you have to do is you have to verify that you own the domain. To do that, you generate and upload an asset links JSON file. There's a couple of helpers online that verify whether the file you uploaded is correct and the one that you have in your app, the mapping is correct with that as well. And then you can share the link with anyone, and they can open the app straight away. Let me walk you through how that works from where we started with the main launcher. Basically, you have to set a second intent filter with the auto-verify flag set to true. That flag tells the Play Store that it should check for the asset links JSON file on the URL provided below. Then you add the action view, category browsable and default. Then you say that this is the one thing that I want to use as the default to view this URL. You then add the schemes for HTTP, HTTPS, and you can add multiple paths or path prefixes to just walk user through to multiple of your activities. For the one that you want to use as the default activity, so when they come from try now or whether they come from your home screen, is the metadata here that has to be a sibling tag to the above intent filter, which just says this is a default URL, and this is where I want my users to come in initially. Like I said earlier, if you don't have a URL in the first place, you don't have to do this. But if you have to have a URL mapping, then this is the way to go. And it's not a lot of work to do. And it gives you users the experience that you can share any link that leads to your app, and any Android user can then open the app straight away without having to install it permanently. And I think for a conference, it's a good use case to have an app that you use once, and you don't have to fully install it. You have the instant app, and for a couple of features, like in our case, it's notifications, you still have to install the app. But it's fair enough to have an experience that you can start straight away without the first steps necessary. Also, there's another thing that we use for app bundles in order to download code dynamically. So going back to the previous section is basically you can do that with the zip and feature instant apps. What we're going on forward now, you have to ship your app as an app bundle, and you have to use dynamic feature modules in order to make use of the PlayCore library. The PlayCore library allows you to download features dynamically on demand, so not during the initial installation, and it's unified between instant app and installed app. So you don't have to do different calls on that. And it does all the heavy lifting. So if you say to PlayCore library, download this, it connects to the Play Store, it downloads it, it puts it in the right place. For instant apps, it puts it into the shared cache there. And for an installed app, it installs it on the device permanently. So how does it work? Well, you add it as a dependency available from Maven Google.com and use it in your project. And then you create a split install manager factory within your activity, hold on to that, create a request where you can install one or multiple modules at the same time. Those module names have to match the module name that you set for the dynamic feature module directly in the manifest of that module. You build it, and then you just tell the manager, start the installation. And that's all the code that you need in order to get started with it. Obviously, there's a couple of things that you have to do around it. I'll go into that in a second. But before we do that, if you don't want to start the installation straight away, there's a way to do a deferred installation. So for example, if you have your instant app, you started it, and you know that your user is in a flow where they're, for example, buying something. So they've logged in, then they're starting the purchase process, and you want to download a payment module, for example. You can do that deferred or during the flow when the user's in that. You can do these installations. Also, uninstallation is deferred at some point. So that means the uninstallation doesn't get done straight away, but at some point where the system says, yes, I'm cleaning up, and this is where this module also gets removed. And you can also cancel installation requests. If for whatever reason you, from the developer perspective, want to cancel that, there's an option to do it. And there's a listener that you can set on the manager. That's my preferred way of listening for the state updates, the split install state update listener. It's quite a word. And that's quite a few things. So usually what happens, the happy path is you trigger an install, your app starts with pending, and then goes to downloading, downloaded, and then there's installing and installed. That's your happy path. That's what happens for an app that is, or for a module that is small enough to not trigger the requires user confirmation. If you go into that state, you will be given some information that you can start an intent with, and that intent allows you to show a dialog that the user can confirm or deny whether they want to install this module at this point. If they confirm that they want to install, you come back into the happy path and continue downloading an installation. At most points of that, your installation can be canceled or in the canceling state, as well as for a couple of reasons, it can fail. So that's the path where you have to handle all those states. We do have a sample available for that, and I'll share URLs for that later on in this session. So you can take a look at how it works. Like I talked a little bit about file size. the limit that triggers, for example, the requires user confirmation coincides with a couple of limits that we have set for instant apps in general and for dynamic delivery. One of the things we do is we don't take the installed size or the downloaded size as the main factor anymore. So if your app on device has a file size that's larger than a limit, then that's all right, because we take the download size into account. So you get some compression over the wire, and that's what we take into account for that. And this will be shown on the Play console as well. So you'll see your download size is this, so you're above or below the threshold. Also, dynamic feature modules don't fall into the initial download size as well. What falls into it is basically your base module and your instant entry module. If you have more than one, which you can have, then it's your base module and your largest instant entry module. And those, currently under a whitelist, have to be less than 10 megabytes. Dynamic feature modules that you download later on, or other instant entry modules that are smaller, don't fall into these 10 megabytes in the first place. But let me tell you a little bit about what this entails. So if your app is larger than 10 megabytes, well, you don't get any of the instant app benefits. Your app can't be discoverable to users as an instant app. If your app is less than 10 but more than 4 megabytes, your app can be seen as an instant app and can be used as an instant app. So you can show it, you can access it through Try Now on the Play Store, and also you can show it in web banners or share it via URLs. If your app or your base module and your instant entry module is less than 4 megabytes, then your app can be discovered from everywhere. That means from ads, from search results. So for example, if you search for the Android Dev Summit app, you will see a search result. If you click that, you will go straight to the instant app on your Android device. That's because it's under this 4 megabyte threshold. And while you're at it, you can continue modularizing. I know modularizing is a tricky topic because it entails some work that some people are not 100% certain how that is done best. We recently went through the whole process with a project that's called Plaid. It's online it's available on GitHub. And I'll talk a little bit about how we managed to move away from a monolithic app to an app that uses app bundles and dynamic feature modules. While it's not currently an instant app, due to the unified approach, uses the same technology underneath that you can use for modularizing an instant app as well. So firstly, what we did is and most apps will do, is we created a base module, which hosts all the domain code and data, so shared access, so shared preferences, login, for example, some repositories, some persistent API calls, and things like that. And on top of that are different feature modules. Those feature modules have their own domain code, their own logic, and obviously the UI, which is only displayed in this module. And that setup can be used for many apps if you have a base module which shares information, and on top of that, the different feature modules. But let me share a little bit on more in-depth what we did. So initially, we had an app, which is the module that most people have. So we had this monolith. And if we shipped as an APK, that's fine, because, well, there's no reason to go into the whole modularization part if we, in the end, have one single monolithic APK that we ship to our users. But since we were considering going towards dynamic feature modules and app bundles, we moved everything into a base, which on the one hand had the shared dependencies, which basically means everything that we include coming from whatever repositories externally, as well as a couple of local third-party APIs and libraries that we have forked and worked with. After we had this, we started working on features that we extracted from the app itself. The first that we started with was an about screen, because, well, an about screen is kind of untangled from most of the stuff that we have within the app. So it's a good starting point for getting our hands a bit wet with how do we, what does it actually entail to make a dynamic feature module? How do we do all those things? Then we went on to do a search screen. And after that, we have two new sources that we extracted into dynamic feature modules as well. And they all depend on the app. And the app and everything shares the information through that as well. You can read up more in-depth on a blog post on the Android Developers Medium blog publication. And also, we do have information available on instant apps in general and on App Bundle, as well as samples on Android dynamic features, as well as how to use instant app without URLs. The Android Instant Apps team is outside at the office hours to share information and knowledge. If you have questions, please come over there. And with that, thank you very much.
Hi, everyone. My name is Artur. I'm a product manager on Android.
Hi, everybody. My name is Arun. I'm in Dev Relations.
And we're here to tell you a little bit about Android Slices, a new API introduced as part of Android Pie. So there's going to be a couple of things that we're going to cover today. The first is an introduction, or we can say a reintroduction to Android Slices, some user experience best practices in constructing your slices, also some more details on search indexing best practices, and finally, through the EAP that we've been running over the course of the summer, we've compiled a list of important developer gotchas for you to keep in mind for when you start building slices when they become available. So let's start by reintroducing slices. Before we get into it, I just want to remind you of some resources that are already available for you to start looking at. We introduced Android Slices as this year's Google I/O, and so you can find more documentation details at g.co/slices. As well, you can also look up our I/O session video, Android Slices, Building Interactive Results for Google Search. And that'll give you a lot of information on constructing slices, building a custom template, and building your UI for your slice. But as a quick refresher for today, slices are a new way for you to present remote app content in Android. Think of slices as embeddable app snippets, which can be easily inserted inside another app or as part of the system. Slices are meant to work across multiple possible surfaces. And the whole idea of Slice is to be able to constrain, but still provide you with a lot of power in how you express your app across multiple contexts. Slices can contain a variety of different components that you provide, including text and images. But they're also very powerful. They're not just static pieces of content. They can house real-time data, interactive controls, and also talk back to your app on user interaction. And so all of these different examples that you see here are examples of slices that you can build. I mentioned that slices can be embedded across a multiple number of contexts, and we're really excited to be bringing slices to search as the first surface for you to insert your slices. So as users are typing their query in search on Android, you'll be able to enhance the predictions offered by Google with live personal content from your apps constructed through the slices you create. There are two types of slices that you'll be able to provide in search predictions. The first are for app name queries. So if someone's searching for your app, you can accelerate them to a canonical part in your app. So for example, for YouTube, maybe the desired goal is to help users get back to the video that they were just watching. Another use case is for any kind of general term beyond your app name. And so in this instance, users can be typing for mobile data or data usage, and the settings app will present them with toggles to toggle their settings regarding data usage. So how do we build these slices? Well, let's start with default slices or app name slices. It's actually very easy to build an app name slice. First, you just construct a slice as you normally would. Android Studio's recent updates include tooling to get you started. And what will happen when you create a slice is you'll generate a definition in your manifest, like this one, as well as an extension to the slice provider class. And that'll provide details of how the system can find your slice and what kind of template to offer to the system when it does. To make this slice map to your activity, or to make the slice map to your app name, you have to add the slice content URI to your main activity, and make sure to specify this in the metadata field as pictured here. So this tells the system, hey, this is a slice that I want to point to this main activity, and here's the content URI from which you can reference that slice. The implementation details for general terms are a little bit different. So first, you actually don't provide the same linking in an activity as you would for an app name slice. Instead, you're going to use updates to the Firebase app indexing APIs to expose your content URI for a specific set of keywords. So using the Firebase app indexing APIs, you will construct an indexable as you normally would. That'll have maybe a public URL. It'll also have the name for that indexable content, some very targeted keywords for users to find that content, a description, and then finally, with the update to the Firebase app indexing APIs, you will be able to add your content URI, your slice URI, for this indexable. And so when the user is searching for the keywords that you specified, search on Android will replace that prediction with the slice specified by the content URI in this indexable. Finally, in order for indexables to be translated from their public URLs to their content URIs, you'll need to override the onMapIntent to a URI method in your slice provider. And this just lets you talk between these two formats in order for your content URIs to be visible as a search prediction. Overriding this method also allows us to provide you, the developer, with the flexibility to define whatever URI schemas are most important to you without necessarily attaching them one-to-one. Great. So now we know how to build a slice and also how to expose it to search on Android. Let's go into a little bit more details on what makes a good slice and what are some user experience best practices to keep in mind. So the first is try to focus your slice on one task or a set of tightly related tasks. Avoid making your slice do too many things, and make sure that content in the slice is coherent regardless of where it's embedded. So keep in mind that those slices are currently embeddable as a search prediction for now. We'd like to think that the slices that you build should be reusable in many other parts of the operating system, and you should consider when building your slice for those possibilities. So the example on the left really tries to focus the slice on being able to consume and preview one video. The slice on the right tries to now generalize it to a couple of other functionality like channel selection and so forth, and really stretches the definition and use of a slice, which we discourage you doing. Try to keep interaction in a slice lightweight. Highlight only the most important features, and make sure that the actions that you're presenting to the user are using clear and familiar iconography so they can understand what these actions represent. Avoid making your slice do too many things in terms of the actions that you have. And so the slice on the left mainly focuses on users just listening to the content of playlist and maybe also offers them the ability to like certain comment. The slice on the right starts really leaning into all the different items you can do with all those playlist items, and that's probably functionality that's best served to be done within your app. When sharing your slices to different platforms, make sure you're surfacing recognizable features and content so that users know that they're able to query for them. And when they do query that for them and see it as a prediction, they can understand how it might have appeared for that particular query. Aruna is going to go into a lot more detail as to what those different cases are. But as a general principle, try to keep that the case and avoid promotional or advertising content in your slice. And finally, have your slice focus on accelerating critical user journeys and try to make sure that the slice helps the user accomplish as much of that journey inline as possible without having to go into your app, by providing all of the necessary information and necessary actions that the user would need to accomplish that action. And so you can see consistently with all of the cases on the left, what's happening is the user has all the stuff that they need to know to understand what the slice is for, what kind of information it's representing, what kind of actions I can do with that information, like changing the song, adjusting the temperature, or adjusting the brightness. And they don't necessarily need to click into the app to do that. The slices on the right are missing some critical piece of information or some critical component as part of that user journey, and it requires users to basically, it adds an additional point of friction for users to complete the task that they want to complete. So that was a lot of information on how to generally build great slices. There's going to be a lot of critical advice for building great slices for search that Arun is going to go into.
Thanks, Arthur. So here are some of the main buckets when you think about use cases for building slices. Use cases should be familiar and hyper-relevant, such as requesting a ride on a ride-sharing app. Use cases should be targeted rather than surfacing all content in your app. And finally, build slices to recall and re-engage with content that the user has already previously seen, rather than just discovery-oriented use cases. Next, we'll see some more guidelines around the type of content that you could surface in slices and the data that needs to be indexed. Slices should be targeted and personalized. Consider the example of a video streaming app that shows slices when a movie that a user is searching for is available in their app. The app could index movies liked by the users previously, or just movies curated based on users' in-app behavior. Do not create and index slices for all movies in your database, or even just the top 200 movies. Slices should give users meaningful controls or information. As an example, a ride-sharing app is building slices so that users can request rides to places that they are searching for. In this case, create and index slices for ride requests based on users' past history, or just ride requests to current popular places near the user, such as concert venues. Avoid creating and indexing slices for as many places as possible in the user's geographic area. Slices should give users timely information. Let's say that a smart home app is building slices so that users can control lights in their home. The app could surface a light control slice when the user is likely in their home. It's not recommended to create and index slices for controlling lights at any time or in any place. Here are some more examples of the type of app content to index and display in a slice. A food ordering app can easily fetch relevant real-time data, such as food price, when the user refreshes the slice. Similarly, a news app slice can index and display morning digest to the readers. Travel and local app slices can enable users view their personal content, such as bookings and upcoming hotel and flight reservations. Let's now see how to keep your slices fresh. When a slice is indexed, the indexable object created includes both the slice metadata as well as a cached snapshot of the slice. And in order to ensure that the slice that you provide to search autocomplete is always accurate and is not stale, you should set a time to live in your slice. This time to live field is used by the Google search app to ensure that stale caches are not displayed. In this code example here, the time to live for the weather slice is set to 1 hour expiration. And of course, if your slice has content that is not time sensitive, just use a time to live of infinity. In order to present fresh data to the user, also periodically reindex your slices in the background when content changes and only when content changes. Do not re-index more than once per day to avoid battery issues. Earlier, Arthur showed us how to set keywords for general term slices using the Firebase App Indexing API. So what are some of the best practices for keywords? Limit keywords to 10 per slice. And account for likely permutations. For example, music volume instead of media volume. But don't account for all misspellings. This is probably the most important. Avoid keyword stuffing. So use the minimum number needed per slice. So your app slice will be demoted in search rankings if you use too many irrelevant keywords that users don't end up tapping on. So what determines if your app slice appears when the user searches for a keyword in the Google search app? This is the biggest question we get from developers. The most important signal is the number of times that the user uses your app on their device. It's also important that the user has viewed the content previously and interacted with it. And finally, in order for us to know that the user interacted with the content on your slice, log user actions through the app indexing API. We'll conclude our session today by sharing some of the lessons learned from the Slices Early Access program. Content URI versus deep link URLs can be confusing. As Arthur mentioned, content URIs are mentioned with a slice and start with content : // whereas deep link URIs are associated with an indexable and start with HTTP or HTTPS. Content URIs use the package name, whereas deep link URLs follow the website or the reverse of the package name as shown in the example. And finally, when you see a content URI, think of a slice. Keywords must be included in the slice title or subtitle. Else, the slice will not be displayed when the user searches for keywords. This is done in order to ensure that relevant content is displayed to the user when they search for something. How do you handle location? Slices do not provide location to apps, and therefore use the last cached location while displaying a size. Reindex your keywords based on the last location. However, also note that indexables are not instantly updated, and frequent indexing may lead to battery issues, as we mentioned before. So keep in mind the best practices for handling location changes for your app, and just apply them to their slices as well. It's recommended to keep the slice initialization short. The onCreateSliceProvider method is called for all registered slice providers on the application's main thread at launch time, and therefore do not perform lengthy operations for the application startup will be delayed. If you have multiple indexables, as in the case of apps with multiple slices, pass in all the indexables together, as we'll show in the code example. And also make sure to test your indexables. If one indexable is invalid, the entire update call will fail. So here is a small code snippet that shows it, how to pass multiple indexables to the Firebase App Indexing API. So now that you've built your slice, how do you test it? Use the Slice Viewer Debug APK to view how your slice appears in UI. That's all we had for the talk for today. We would like to give a shout out to all developers in the Slices Early Access program. Thanks for attending and have a fun rest of the session.
Thanks. We are now officially on break, but I do want to point out this is like the worst fab I've ever seen. I think the animation got stuck here. I would recommend people put it in the lower right and not have it be that color. There's just something disturbing about that one. It is snack time. It says on the agenda that it is now tea break. I would like to point out there is coffee as well as tea, and there is also coffee. There's also snacks, and there's coffee, and I have it on good authority. There's also coffee downstairs. There is coffee. Excellent question. Thank you for asking. Let's see. We are back here at 4 o'clock building a great TV app. There's a talk on Gradle best practices in the other room. Office hours are open till 6, and then they're reopened at 8:30 tomorrow morning. See you back here at 4. Thanks.
Hey everyone, I'm Benjamin Baxter, developer advocate for Android TV. Today, we're going to talk about building a great Android TV app. So before we dig into the details, let's talk about the ecosystem. We continue to see 2 times year-over-year growth. We're investing more in smart TVs, set-top boxes, pay TV operators. The ecosystem's been pretty strong. But we're all developers. Let's get into how can you make a good TV app. So before we talk about what the innards of your app are, let's just think about what is a TV? Why is it so important? We have entire living rooms or other rooms dedicated and focused around a TV. It's a pretty key point for users. It's the focus of an entire room. Just think about that for a second. So your app matters. The content really matters. So if we try to think about what is the foundation for an app, the biggest piece is your content. That's your value prop to your user. If we add on to that, usability. How do you make your app easier for users to use? You have great content. How can they discover more of your content inside your app? And if you want to get that little cherry on top, think about the experience. How can you layer in all these extra things to build a sweet experience for users, no matter where they are in your app? We'll dive into each of these concepts, and I'll call them out later on. But the key takeaway is they come for your content, but they stay for your app. So now let's talk about how do you build a great TV app. There's really 3 things to think about. Playing, because content's important. Discovering, making sure they can see other content in your app easily. And distributing, making your content easy to find should be as easy as making your app easy to find. So let's talk about the player. Playback can make or break an app. Let's take a look at this review. Feel free to read. So the key takeaway for me is that it constantly stalls. This app is completely frustrating. They ended up with just a 1-star review just because of their player. And reviews matter. There's whole other talks about Google Play and how to improve your reviews. But the player was the key point here as to why their app was not as good as it could be. So it's very clear to users that the playback is important. They don't want to have stutters and stalls. They want to be able to watch the content. And even in that review, they talked about commercials and ads. And they were okay with it. They just didn't like that they stalled. So even showing things that may be annoying, such as commercials, as long as they play fine, users are okay with it. So the player, we have many options to build a good player. Media player is a great tool, comes out of the box in the framework. You give it a data source, it's able to chug along and play, and you can build a great experience with a media player. If you have more advanced things you want to do, Exo Player is another great tool. We've worked really hard to make it highly customable. There's a bunch of extensions. If you're using Leanback, there's an extension that hooks into the Leanback transport controller. If you're doing ads, there's a whole bunch of ad stitching support. But let's talk more about ads. Ads are important. Your app's going to make money from showing ads. So in a sense, ads are just as important as the content shown and displayed to the user. So focus on ads. Make sure that ad stitching works. Whether you should do it server-side or client-side, these are real considerations you should make for your app. So there's many options for players. Media player, Exo player, build a custom player. But having a player is a good start. But there's things you can layer in. That top part of the pyramid, the experience, there's things you can do to build an experience around the player to make it even better. So we talked about this at I/O this year. Playback controls. Everyone's phone should be ready. Here we go. OK, Google, skip 5 minutes. OK, Google, pause. OK, Google, play. These types of transport controls can be commands through the assistant. Adding this extra little feature, this little nice nougat of delight, helps build that experience for your app. This all works with Media Session. So if you implement Media Session callback, you get all of these features for free. And since I talked about this at I/O, and there's been other talks about media session from other people, I'm going to just jam through this fast. Pay attention. Here we go. Boom, beautiful. 6 wonderful methods: pause, play, stop, seek, next, and previous. But in reality, like, that's a lot. It's a lot to think about. All these different cases. But if you use ExoPlayer, this can be done for you. So they've made an extension that manages media session for you. All you have to do is connect the player to the media session, and it all works for you out of the box. Making a media session is also pretty simple, and there's tons of documentation and talks about media session. I'm not going to go too deep into it, but you just need to make sure that you set the media session to be active, set the controller, set anything else you need to set. Set the current state. Are you currently playing? You know, what position are you in? Set up your media session to be what you need it to be. And once you have a media session and you have an ExoPlayer instance, connect them. So there's an extension library, media session connector for ExoPlayer. Here you just add in the media session as a constructor parameter to the media session connector. And then you set the player to your ExoPlayer instance. This media session connector understands how to set up the callback, all the edge cases around playing and seeking. You know, you don't want to go past the end of the video. You don't want to rewind before the video starts. It handles all those edge cases for you. In this example, we are saying set player, and then null. You can set a custom playback preparer. There's other customizations you can do as well. So if you're a music app and you have a custom playlist and you want to set a different order for how the songs go through the queue, you can set a custom queuing mechanism on the extension. That's it. 3 wonderful lines of code, and assistant's already taken care of for you. All of the default behavior you expect, done. So having a great player is great. That was just one example of how to layer in that experience to make a player even better. We're going to skip ahead to discovering content. So the whole point of discovering is you want users to stay in your app, and you want them to discover and watch content faster. So let's look at this review. I love the first sentence. They love, love, love. So many loves this app. So the key takeaway here is it was a 5-star review, and they loved all of the content was there. Easy to find. They can do whatever they need to do inside that app and watch what they want to watch. Funny story, that's the same app that got the 1-star review. So even though they had a bad player, they worked on discoverability, and they're still able to have good review in the Play Store. So how can we make content discoverable? You know, everything kind of happens in 3s, and that's like a rule of comedy. It's a really good rule in life. In this case, discoverability also happens in 3s. You can work on in-app browsing, search with the assistant, and the home screen. We'll start with in-app browsing. There's a beautiful library, Leanback. If you've done TV development, you're very familiar with it. It's a templated UI system for you to just plug in data, and it works on building the UI for you, so you don't have to worry about all the focus handling and all the user input. You can just supply, hey, here's the content we have, and it will show it for you. It's not just how to browse content, though. Leanback also works and shows details. So there's a whole bunch of information about content. You have duration, content rating, the Rotten Tomatoes score, the album, artist, and I can keep going on for the rest of the 30 minutes of this talk, but I think you get the point. There's tons of information. The cool thing about it is you can show it using Leanback, but you can also show it in multiple other places on the home screen in search. And by showing all this information sooner, it lets users make these micro decisions much faster, and they don't have to go in and out to figure out what they want to watch. So make your users' lives easier by showing them all this data sooner. Let's look at another example, search. Again, we talked about this at I/O, and there's tons of documentation on this. So I'm going to kind of breeze through some of these things quickly. Search is all supplied with a content provider. Content providers are pretty simple. They return a cursor. You're able to do whatever you want in the background with this content provider. So boom, magic content provider. You perform a search, and it returns results. If this did a network call, maybe you have a bunch of POJOs. If this was a database call, you're going to have a cursor. And that's fine. The trick for the search provider is that it needs to return results that match the search manager's criteria. So search manager is just a strict way of saying, hey, this cursor has a bunch of columns with these names. And then the assistant's able to pull in from that cursor and say, oh, here's the title, here's the duration, and is able to figure out what content's where. Super simple to do with matrix cursor. And we'll dive into this a little bit closer. You just need to take each of your results, add them as a row into the matrix cursor, and then return the matrix cursor. The matrix cursor is really just like a mock cursor. It's a 2D array, essentially, under the covers. So if you don't have to go about, how do I store all these in a database with these column names, you can just mock it out at the very end of your search. So mapping, this is where the hard work happens. You have a matrix cursor, and it takes in a query projection. This query projection is going to have all of the columns defined that match the search manager. So here we have suggest column text 1, typically is the title of the content, an action, a data ID. The ID is what's unique to your content inside the app. And then when you go to convert your content into this row, you just supply an array of objects. Here's the ID, here's the name, and they correspond to the order in which that query projection was. So the ID, the title, the action, etc. All the fields you have, you can return back. So a search manager, and with searching with the assistant, you don't have to do all this extra work. You can use matrix cursor to make that returned result much faster. Home screen. We've talked about the home screen for the past 2 IOs, so I'm not going to talk about the old. I'm just going to briefly cover it, and then we'll talk about some of the new stuff that's happening. The home screen has 3 key parts. Your app can have a channel, your app can iterate with the play next row, and for video apps, you can have video previews. We've seen up to 2x increase in engagement when apps have video previews. They look wonderful. They can be as simple as a trailer for a movie or a recap for a TV show. But they take a little bit more work because it probably requires a content team to make that content for you. I'm not going to talk about Play Next or video previews since we talked about before, but let's dive into channels. So just to recap, building a channel is just inserting into a content provider. We have a channel. We get a builder. We set the type to type preview. We give it a name, a description, a deep link, so when they open up your channel, it's able to open into your app. And you set an internal provider ID. This is an ID that your app wants to keep track of and knows about. Then you just get a content resolver, you call insert, you give it content values, and you're good to go. Once you've stored your channel, you parse out a channel ID. You do some stuff, maybe you want to keep track of that channel ID for synchronization. And then you set a logo. So channel really consists of a name, a description, a deep link, an internal provider ID, and a logo. Those are really the key pieces of a channel. So what just happened? We created a channel, we inserted it, and we stored a logo. So we really did 2 things with the home screen. Insert the channel, store the logo. So as of AndroidX 1.0.0, we have a new API. This API looks very similar, small differences. We have a preview channel helper class. It takes in a context, and then it does a bunch of lookups to get the content resolver for you, so you don't have to do context.contentresolver.insert. It does all this work for you. It makes a channel. So you have your builder, you set the name, the description, the app link, and the intent provider URL, and you think you should set the type. But this class knows that it is a preview channel, so it already knows the type is type preview, And you don't have to set the type. Instead, you can set the logo. Now, all this stuff is contained in one unit, and you can just call the helper.publishChannel, give it the channel, it figures out all of the work for you. And you get the channel ID back. So what it does under the covers, it inserts the channel into the provider, and then it goes to add a logo. If the channel isn't able to be inserted, maybe you have bad data and you're hitting an error or something, it will return an error back to you. If it is able to insert the channel, it tries to store the logo on that channel. If the logo cannot be persisted, it throws an exception, wraps it all up, unwinds adding the channel so that you don't end up with like half a channel on the home screen. It essentially treats everything as an atomic unit. Pretty convenient. It doesn't just publish channels, it does everything CRUD does. So we've already talked about publishing a channel. You can read all of the channels. You can even get individual channels. You're able to update a channel, and you can delete them. And I'm only talking about channels, but all of this also happens for preview programs. And there's also support for the Play Next row in this class. But there's two options to do it. Which one's better? You could say, I just want to use content providers. I'm able to fine-tune the performance. I can do batch inserts, bulk operations. I can get lower-level control. I don't need an entire program with all that metadata. Maybe I just want the title and duration. And now I can slow down that query projection and have faster results. And it's based out of the framework. You don't have to do all this extra work to access it. You get it out of the box from the framework. But if you want to use AndroidX, you get more convenience. You don't have to worry about all the nuances of a content provider. It's a one-liner for all intents and purposes. And you get all the fun benefits of having the AndroidX in your app. So discovering content's great. There are 3 ways to go about it. In your app, searching with the assistant, and on the home screen with channels. But how do you make your app discoverable? The third thing. The App Store on TV is a bit different. It filters out a bunch of content. It wants to make sure only apps that are designed for TV will be shown. So when the user opens up the App Store, they're only looking at apps that can be played on TV or can be installed on TV. Trying to navigate the Play Store and make your app stick out can be hard, but there's 3 simple things you can do to have your app appear on the Play Store. First thing is to declare features. And as slide says, even if you don't use it, there's a giant asterisk. Don't start declaring like Bluetooth just for fun or location just for fun. There's 2 features that really matter. So the first one is touchscreen. You want to declare that as false. It's not required to have a touchscreen. This isn't a phone. This isn't a TV from way back in the day. These are smart TVs. You don't need touchscreen support. The second thing is to declare leanback as true. This tells the Play Store, hey, this app is designed and ready to be deployed on a TV. But if you have all of your code in a single code base and you're making a single APK that deploys on both mobile and TV, set leanback to false. This still tells the Play Store, hey, this APK is compatible on both mobile and TV. The second thing you should do is try to be visible in the launcher. Now, if you're a headless app like a screensaver or a keyboard, just go away for 2 minutes, and I'll see you then. So to make your app visible on the home screen, you need to supply a banner. You can define a banner in application, or you can set it in your activity. The launcher will go in through the manifest, find this resource, and this is what it uses to show your icon on the launcher. But once the user selects your icon, it needs to launch something. So the launcher fires an intent, and you need to have an activity that accepts this intent. It's called the leanback launcher intent, really cleverly named, does exactly that. So from the launcher, it will trigger off your leanback experience. So there's 3 things you need to have. 1, declare the 2 features so that your app will be found on the Play Store. 2, have a banner so your app shows up on the launcher. And 3, have a leanback intent so that your app launches when the user wants to enter your app. And that's it. You're ready to go in the Play Store. This talk is done. All right. But in a sense, that's kind of the minimal viable product. You're able to have a strong player, you're able to have easy to find content, and you're able to distribute on the Play Store. That's just a good app. You know, how do you make it great? To start with this, you should look at your users. Imagine all of your users on a spectrum. They start from one side of the spectrum. Hey, I bought a TV because it's cool, you know. Everyone's doing it, I want to be cool. Sits in my closet, but I have a TV. You know, the next side of the spectrum, oh, I love watching TV. Every week I watch this show. This is great. You go a bit further down, oh man, I love How to Get Away with Murder. Viola Davis is awesome. Hey, maybe I should watch Suicide Squad. She's also in that. Then the far extreme, you know, maybe the better examples for sports. Hey, I'm watching the sports ball game. Here's a fantasy team. Here's a jersey of the player I like, and I just want to keep going and going into it. The side on that side, the left, is what's called the lean back user. They're just going to be sitting back watching TV. That's all they want to do. The side highlighted, this is what you can call the lean in user. They're sitting on the edge of their seat. Oh man, this is awesome. Who are these people in this show? And they're going deeper into the content. Everything we've talked about up till now, having a good player, making your app usable, this is more for the lean back, the right side of the screen. But if we think about it, how can we tap into that lean in user? Here we have another living room, a very beautiful living room. I wish it was mine, but it's not. But if we look closer, you'll see a camera, microphone, tablet, phone, and then as you start to think about it, the TV is the centerpiece of a living room. There's so many devices around. You know, you don't have to just do stuff on TV. You can tap into everything around the living room. That's why I love Android TV. It's like the focal point of everything that's happening. So in concept, again, we're going to do this in threes, because threes are great. In concept, if we want to tap into these other surfaces, what should we look to do? First step is just controlling media. The playback controls we talked about earlier is a great step. It's going a little bit farther advanced. You're building an experience around your app. Maybe for another option is to have notifications. Hey, the big game's about to start in 5 minutes. Do you want to watch on your TV? Second pillar is more about going deeper into content. Who's the cast and crew? What are the behind the scenes of this production? You know, are there extra sponsored content that I want to know more about? And then the third pillar is about reducing friction. How do I install your app? Okay, it's installed. How do I sign into your app? I want to make a payment. How do I authenticate that payment in a secure way outside the TV? So let's look at an example. You may or may not know it, but everyone here who set up an Android TV has already done that third step, that frictionless interaction. The Android TV setup actually does this for you. During the flow, they say, hey, do you want to set up on the phone? They give you a strong UX indicator. You're going to pull out your phone. You get a notification. You say, hey, yeah, this is me. This is my account. And the TV takes over from that information. And it was really frictionless. But how did they do that? It's not magic, I promise you. It's something you can do today. You can use Nearby. So the Nearby API has been out for a while. But it's really interesting when you try to use it on TV, what you can do. The way it works is you're going to set up the TV to be the advertiser. And then the phone's going to come out and try to discover, hey, there's the TV. You do all the work you want to do on the phone, and then send it back to the TV. Nearby is going to set up an offline peer-to-peer wireless connection that's encrypted, and you don't have to worry about a lot of things because you're going to have this intimate connection between the phone and the TV. Let's dive a little bit deeper. So getting started with this, let's start on the TV side, because I'm on Android TV, so I'm a bit biased. We're going to start on TV first. TV is going to start advertising. The way you do this is you set up nearby.getConnections client. Nearby is just a nice singleton helper class from the Nearby API that has all these things to help you get started. You call start advertising. You're going to give it a name, a service ID. Package name is perfectly fine. You're going to give it a connection lifecycle callback. And you're going to set a strategy. Cluster is a really good strategy. If you notice, there is also a P2P point-to-point strategy. And you might be, yeah, it's one TV, one phone, point-to-point. This sounds great. But if you try to do like multi-device setup, I have a TV in my living room, one in my bedroom, one in my bathroom, all of a sudden, that point-to-point breaks down. So to make a more robust app, you should think about using cluster. You also set success and failure listeners. Now, these listeners aren't saying, oh, I've been found, I've advertised and now I'm found. These listeners say, you are able to start advertising. So they're great for debugging and adding extra information inside your app. The big elephant on this slide, though, is the connection lifecycle callback. This callback talks about how the devices will talk to each other. You know, what's going to be said is later, but how are they going to say it now is handled in the connection lifecycle callback. Simple 3 methods: uninitiated or uninitialized, results, and disconnected. They're pretty straightforward, but let's dive in a little bit more. So when a connection is initialized, that means the phone requested a connection. You're going to prompt for security and do a couple things, but eventually you're going to say, nearby.getConnections client, accept connection. Once the connection's been accepted, you'll receive a result. Based on that result, was it okay? Continue on. Was it rejected? Maybe ask for another retry. But based on that result, you should handle appropriately. And the last one on disconnected is pretty simple. Just clean up any metadata you may have started collecting. The big line here is the connections client accept connections. And here you pass in a payload callback. This payload callback is going to be what the devices communicate. So you should have a contract on your phone and on your TV for what they're going to say to each other. Hey, phone, we want to do this. Hey, TV, we're going to do this. This is all handled inside the payload callback. So here are a couple tips. What you're going to communicate is very specific to your app, but here are some tips. The payload received and payload transfer update are the only 2 methods you get. They're pretty succinct, pretty good methods, though. On payload receive, if you want to send an acknowledgement back, hey, thanks for telling us this, phone. We're going to send back an acknowledgement so you know the message has been received. It's really easy. You just call send payload. You give it the endpoint ID that you received the payload from, and some body. In this case, it would say ACK, or acknowledge. If you want to disconnect, hey, I received this payload. I want to disconnect the connection and close this session. You should do that in the transfer update. In the transfer update, you should check to see if it's in progress or not. If you're sending small messages like ACK and send, those are pretty fast. But if you're sending something big like a file, that could take a while, and you want to check to make sure all the bytes have been sent. Once all the bytes have been sent, then you can call disconnect from endpoint. So to summarize the TV side, you're going to advertise, hey, I'm a TV. You're going to accept the connection, and then you're going to communicate. But on the phone, what happens on the phone side? It's going to look very similar. You're going to discover the TV this time. You're going to request the connection, and then everything after that is going to look like the slides I just showed you. So to discover the TV, you have the nearby connection client again. This time you call start discovery. Mind blown. You're going to give it a service ID. Now this time I'm using a constant, and there's a reason for the service ID. Depending on your app, should either be the package name or the constant. If you have a package name that's the same for both your TV app and your mobile app, it's going to work great. But if you have something like com.mycompany.android or com.mycompany.androidtv as your 2 package names, imagine they're kind of on their own channels, and so the nearby connections library won't be able to find the phone and the TV. So having a service ID that's used by both sides is a good practice. Then you're going to give it a mobile endpoint discovery callback, because I love really big words. And then you're going to set a strategy. This strategy should be symmetric to what you set on TV. So I urge you to use cluster for this use case. You get listeners again. These listeners are pretty important. These say you are able to start discovery. This does require location permission because it's going to use Bluetooth LE, then default to other ways to find nearby people. So if you get a failure listener, maybe it's like, oh, permission for location hasn't been enabled. So these are great for debugging and trying to urge the user down the correct path. So the second part, accept the connection. Really simple. You have that mobile endpoint discovery callback, and it has two methods. You either found an endpoint or you lost an endpoint. Pretty simple. If you find an endpoint, go ahead and request a connection. This will trigger the onConnection initialized on the TV that we saw earlier. If you lost an endpoint, maybe the user walked too far away from the TV and is now no longer nearby. Or maybe they gave up and just closed the app and said, forget it. Hopefully it's the first for you, not the second. You just clean up whatever metadata you had collected already. Everything after this is identical. You're going to have a connections lifecycle callback that handles how they communicate, and then you're going to have a payload callback that says what are they going to communicate. And that's it. That's pretty much Nearby in a nutshell. But Nearby is a cool tool. It's nice to have in your toolbox of kits for how to add more experience to your TV app. So let's go down payments. Let's look at one more example. Payments, I think, is kind of cool. It adds this family-friendly idea. Imagine you're at work and your kid is at home and they want to buy the next season of a TV show. You get a push notification. Hey, are you sure you want to purchase this TV show? And you say, oh, man, my kid's at home buying stuff. No. Or, oh, man, my kid's at home. Yeah, they're bored. Let me use my fingerprint or Face ID or anything from the phone to authenticate yourself. And all of a sudden, you just enabled a purchase at home from your office. I'd argue that's not Nearby. If there was an API, it'd be called far away, right? And Shrek might have been as close to far away as I've seen, but I have not seen that in Android. So in this case, Nearby is not a good fit. It's a good tool in your toolbox, but it's not necessarily the best fit. Maybe there's another good fit. Let's talk about that example one more time. You get a push notification, and it says, watch on TV or watch here. This is the big game. You want to watch it. Watching on a small phone, yeah. Watching on a big TV, awesome. You could use Nearby to figure out proximity. Yes, they're close to the TV. We should show the Watch on TV up button. That's a great use for Nearby. Receiving the notification, this is a great example of content immersion. As soon as you said Watch on TV, the background lit up. You're in this immersive view. Here's the schedule for the game. Here's some highlights. Here's the score. And then whenever the user wants, they can just put the phone to the side. It's very non-intrusive, and they can focus on the game. So in a sense, this was kind of kicked off from a notification. In a way, you would say, hey, that was more of a push model. Nearby feels more like a pooling. I'm pooling a conversation between the two devices, whereas in this case, you're more of pushing that information to the user. And there's a talk about Firebase Cloud Messaging after this, and I won't step on their toes too much, but we'll just talk about it for fun. What's the worst that can happen? You set up a Firebase messaging service, you receive a message, based on that message, you should have some action. Here's what to do when you receive that message. If that action happens to be, hey, watch this movie or watch this game, start watching, and you're good to go. Start watching literally should launch an activity. This is the Android Dev Summit. I'm assuming everyone has launched an activity before, but just in case. We set up an intent. We give it some extras like, hey, here's the video to watch, and we start an activity. Beautiful. The question really comes down to what happens when the TV screen is off. I'm at home, I get a push notification, oh man, the game's about to start. I have to hit power on my remote, I have to tune to the channel. Man, this is first world problems at its finest. But you can solve those. We have that fragment activity that's your player. When you set up everything, all you have to do is just call set turn on screen to true. Now this is a really cool API on activity. This is actually introduced in OMR1. So if you're on API 27 or higher, you should do a check. Hey, turn on screen to true. Otherwise, you can just add the flag. So to summarize, how to build a great TV app. Start with your player. Your content is king. So really focus on the player. Whether it's an ad or whether it's actual content, make sure your player is solid. Next thing, how do you make your app more usable? How do you get that lean back experience so that users can quickly find other content to watch? The third pillar is distribution. Is my app set up to be deployed on the Play Store correctly? Once you have all three of these, you end up with happy users. And who doesn't want happy users? But if you want to take your app even further, evaluate your users and layer in these lean-in experiences. You know, how do you do payments, having that push notification for that media control? How do you add that immersive content? Here's the details of the game. So thank you. Everyone, go build great TV apps. If you have any questions, you can come see us at the office hours. Thank you very much.
The next session will begin.
At Google I/O 2017, we opened the door to Room, a persistence library that provides an abstraction layer over SQLite. Now, Room has reached version 2.0 and is part of Jetpack. We fixed the bugs you reported and added some of the features you asked for. Let's go over Room's main components and see what queries are supported, how to implement migrations, and how to test your work with a database. Let's say that you want to have a table of users, and you want every row of that table to be an instance of the user class. Annotate your class with that entity, define the table name if you don't want to use the name of the class as table name, set the mandatory primary key, and the optional column info, but only if you want to change the name of the column. Otherwise, the field name is used. And that's it. Room will take care of the creation of the user table for you. So that's how the entity is done, but we need a way to access the data in the database. We do that with Data Access Objects, DAOs for short. More precisely, create an interface, annotated with @DAO. In this interface, declare all the methods needed to work with the database, annotating them with the corresponding SQL query. Room takes care of implementing these methods for you. The supported queries are insert, update, delete, query, and raw query. All of them, except raw query, are checked at compile time, which means that if you write an invalid query, you'll find this out immediately. The class that puts together the entities and the DAOs is the Room database. Create an abstract class that extends the Room database. Annotate it, declare the entities and the corresponding DAOs. Let's take a closer look at the queries. The return type of query and raw query can be the entire entity, but also a subset of its fields. If you're working with Guava or with optional from the Java util package, you can also use them as return types. So this means that if there are no values to satisfy your query, then your query will return optional.empty or optional.absent, depending on which optional you're working with. All of these queries are synchronous, meaning that they will be run on the same thread you are triggering them from. Room ensures you follow best practices by throwing an error if you run queries on the main thread. So use your preferred method of handling threads in Android and make sure you're off the main thread. Room also supports asynchronous query when working with live data or RxJava. What's more, the queries that return live data or flowable are observable queries, meaning that you will get notified every time the data in the table or tables updates. Whenever you alter your database schema, either because you've added or renamed a column or a table, you need to tell the database how to handle that change. In order to do that, in your database class, you'll need to, first, update your database version. Second, implement a migration class, which defines how to handle the migration from the old schema to the new one. And then thirdly, add that migration class as a parameter to the database builder. After triggering the migrations, Room validates the schema for you to ensure that the migration was done correctly. If you don't want to handle migrations and you don't need to preserve your database data, call fallback to destructive migrations when building the database. To destructively recreate the database only from a specific version on, call fallback to destructive migration from and provide the number for that version. So we have our entities, DAOs, database, and migrations. How do we test them? To test the DAOs, you'll need to implement an Android JUnit test that creates an in-memory database. The in-memory database holds the data only for as long as the process is alive, meaning that after every test, the database is destroyed. To test asynchronous queries, use an instant task executor rule to execute each task synchronously. In your app's implementation, you'll end up referencing the DAOs in other classes. To unit test those classes, just mock the DAO or implement a fake version. Here's another tip. To implement espresso tests covering code that uses asynchronous queries, extend the counting task executor rule to count the tasks as they start and finish. Finally, don't forget to test the migrations. Export the database schema first and then use another handy test rule, the migration test helper. This class allows you to create the database in an older version and run and validate each migration. All you need to do is check that the data you inserted in the older version is also present after the migration. Okay, so let's summarize this. Less boilerplate code, compile time check queries, ease of implementing migrations, a high degree of testability, and checks for keeping the database work away from the main thread. All of these qualities of Room make it easier and more pleasant to work with databases, helping you deliver better apps.
It's best practice to provide resources for supporting all devices, but sometimes it might seem like you need to make a trade-off between supporting devices and a small APK. Now, if you're not using multi-APK, supporting different screen densities, CPU architectures, and language could account for a pretty big chunk of your app's APK size. That's why we've introduced a new publishing format called the Android App Bundle. It'll mean smaller downloads for your audience and easier artifact management in the Play console for you. An app bundle is a single comprehensive build artifact that you upload to Google Play instead of an APK. Compared to multi-APK, an app bundle delivers smaller apps to users and is simpler to manage because it's only one build artifact. When Google Play has your app bundle, it uses a new process for delivering APKs called dynamic delivery. Put simply, it only sends the portions of your app that each user needs. Now, just using the new app bundle format will automatically give your users APKs with only the language, screen density, and ABI resources that they require. And it requires no code refactoring from you. Building an app bundle is just a matter of selecting the right build output. When using Android Studio, here you'll see the option to generate a signed app bundle. Select building a bundle instead of an APK, provide your key, choose the destination folder, and you're done. You'll then have your shiny new app bundle. You'll also need to enroll in Google Play app signing in the Play console. Google Play is essentially generating optimized APKs for your users, so you need to give it the ability to sign those APKs for you. App bundles are supported by Google Play right now. The technology that Play uses to generate APKs from the bundle is open source, so in the future, your app bundle will work with other app stores that enable support. Bundles work for all devices. Devices running Lollipop and higher get the greatest size benefit from dynamic delivery, but pre-Lollipop devices will still get a multi-APK style APK, which is automatically generated by Google Play from your app bundle. Let's go ahead and take a closer look at how Google Play actually uses this bundle, what dynamic delivery is doing, and how users get their APKs. In the past, you'd upload an APK, and then Play would then serve that same APK. When you upload an app bundle, Google Play takes that bundle and splits it into multiple smaller APKs, known as split APKs. The part of the app which is always downloaded is placed into a split APK called the base APK. When using a bundle, Play automatically makes split APKs for resources, assets, and native libraries. These resource-specific split APKs are called configuration APKs. Let's take a look at an example. I'm an English-speaking user on a Pixel 2 XL, with 560 dpi resolution running on an ARM64 processor. If I install your app, Dynamic Delivery will find just the split APKs that I specifically need. These split APKs will be delivered down to compatible devices and behave like a single, customized APK that's optimized for my device. For earlier devices, Dynamic Delivery will send down a multi-APK with resource-appropriate ABI and density resources. With the introduction of the Android App Bundle and Dynamic Delivery, we're allowing for automatically smaller apps and a smoother deployment process. In addition, the App Bundle format also introduces dynamic features, released in beta. Dynamic features allow you to modularize specific features and then deliver them to your users on demand. For more information, check out the links below. If you're curious about bundleifying your app, the best place to get started is g.co Android App Bundle. Happy coding!
sit here? Yeah, I'll sit. Hey, good afternoon, everyone. Thanks. So I'm Adam.
I'm Chris.
And this is Android Suspenders. Today we're going to talk a little bit about Kotlin coroutines. But to get started, a little bit of background. Many of you are probably familiar with us already, is the idea of Android's main thread. And just like almost every other UI toolkit out there, Android exposes a single UI or main thread for doing updates to parts of your UI. So some of the things that you might find yourself doing on the main thread, inflating views. You could be doing measure and layout operations to change the shape of your view hierarchy. You could be drawing, or many other things, really, like processing input events, and so on and so forth. So today, you're probably familiar with this 16 millisecond time limit. The vast majority of devices out there have a refresh rate of 60 hertz, which means that you have just over 16 milliseconds to do all of the work necessary in order to deliver a smooth frame rate. So what happens when that display rate goes up? So 90 hertz means you have 12 milliseconds. 120 hertz means you have 8 milliseconds. And you have less and less time to get some of this work done. If you take a look at a systrace, you'll usually find that the things that cause you to miss a frame and thereby have kind of jank in your application is really app code. Like if you're binding items to a recycler view, reading from a data store, so on and so forth, these are all bits of work that it would be really great if we could keep this off of that main thread and out of this critical path. So how do we fix it? Well, this talk isn't about achieving 8 millisecond refresh boundaries. This is about making use of the resources we have available. And all the phones that we have multiple cores in them today. So how do we actually make use of that? Well, some of you probably remember this thing. It's been around for quite some time and has a lot of issues. It composes a little bit badly, has some issues around rotation. It's really easy to get wrong. There's executors, which most Java developers are familiar with. And this kind of lets you share some thread pools, which is nice. But it's otherwise kind of a really raw API. You can build things out of it, but it's not really convenient to use on its own. Loaders. Loaders are a thing that were certainly out there that solved a few problems, but it was pretty narrowly scoped. It's really now deprecated, so there's not a whole lot there. We can use futures. There's listenable future, which has started showing up in more AndroidX APIs. But you may not want to pull in all of Guava and all of the infrastructure that really helps you leverage some of the things that you can do with it. And unless you're working on MinSDK 24, you can't use completable future either. And really, there's a whole bunch of other reasons why you might not want to use that to begin with. So there are a lot of other libraries out there. I mentioned Guava. Guava is certainly one that you can pull into your app. RxJava is super popular. It's a great library, does a lot of things well. But if you're sitting here in this talk today, you're probably here to talk about coroutines, which is a new feature that went fully stable in Kotlin 1.3 just this fall. So why should we use them?
Great. So when I think about this question, I'm thinking about what does your typical mobile app do? And I think for the most part, you can describe them as kind of CRUD apps. And I don't mean the American slang. I mean the fact that they create, they read, they update, and they delete data, usually to some kind of local data source, like a database or whatever it be. And then going a bit further, a lot of apps will also have some kind of sync. So they'll upload data and pull data back from some kind of web service. Now, apps are actually pretty simple computationally. You're not really taxing the CPU that much, really. Yes, the logic can be quite tricky to get right, but actually, they're pretty simple. And of course, Android, we put a lot of stuff in your way. Like we make your life harder. But actually, your apps are actually pretty simple from a logic point of view. So why coroutines? Well, how do they actually fix that? Well, I think they're great for I/O tasks, especially for a resource-constrained system like the phones and tablets that you're using today. Now, you can't create a thread for every network request you ever use, because threads take in the space of about 1 megabyte to 2 megabytes of RAM every time you create one. That's why thread pools actually cache threads for you. Now, coroutines, on the other hand, take in the sort of realm of tens of kilobytes in terms of actually coroutine. They use threads underneath, but they use them in a much more optimal way. Also, in my mind anyway, they have an easier development model. It's a lot easier for developers to kind of come into a new code source, and see an imperative line-by-line coroutine over something like an RxJava chain. Like, to be able to understand what's happening there is, in my mind anyway, easier. And same thing for callbacks. Like, everyone knows about callback hell, and I'm to
go line by line and see where you've been called and stuff. And so coroutines help, hopefully anyway, fix that. So a lot of this talk was written in mind with a sample app that I've been writing for the past 12 months or so called TV. It was originally, I went all in on RxJava. It was RxJava from top to bottom. And I've kind of slowly brought coroutines into it. It's now about 50% coroutines, 50% RxJava. So it still uses both. And I think they both have a place in Android development. And so, yeah, go use both. Now, as Android developers, we have to care about APK size and method counts. Now, in Kotlin, in my app anyway, I'm using 3 libraries from the Kotlin coroutines kind of tree. The core, which contains the majority of what you'll actually use. Android, which adds support for the Android main thread, amongst other small things. And then Rx2, which allows you to interrupt with RxJava. So if you're not using RxJava, you won't need that one, but it's pretty small anyway. Now, if you actually pull down those jar files, just from Maven Central or wherever, they would come to about 774 kilobytes. So that's quite big, and it should be alarm bells are ringing. But once you actually put that in your APK, it actually shrinks down because it's packed in, and it comes down to about 500 kilobytes. But that method reference is actually still quite high. That's like 5% of your 64K. As soon as you turn on Minify, and now this is just tree shaking, so there's no optimization turned on here, or ProGuard, they both have similar results. You're looking at about 113K, so a lot less. And again, the method references has dropped. But as soon as you turn on optimization, and then you go through all of trying to fix all the ProGuard rules, you're coming down to that magic value, which is less than 100 kilobytes. And again, your method references are now 834. Like, it's less than 1%. Well, it's 1% of your references. Now, one thing to note when you're using ProGuard or R8 is that you need to use this rule. It's not currently bundled with the jars, but hopefully it'll be added soon. But it's a pretty simple rule to add.
Right. So hopefully by now you're thinking about how you might use coroutines in your app. So let's go ahead and talk a little bit about actually writing them. So anything that you can do with a one-shot callback or future, you can do with a suspend function. Everything with coroutines is kind of based around this idea of a suspending function as a basis for creating APIs. Suspend functions can stop and yield their thread without blocking, and they can be resumed later like a callback. And they can only be called from another suspend function, so just to set up all the machinery involved in that. But the core thing is that all of this kind of fits on one slide. There's less to remember. The rest of the language still works the same in the presence of suspend functions, and we'll spend the rest of the talk talking about that. So here's a suspending method from Chris's app. Actually, this is a data repository for TV shows. So you go ahead and you call this update show function with an ID. We get some shows, and we get a little bit more data from a remote source, and a little bit more data from a second source. Finally, we merge all that together, and we save that data. So these 3 main tasks where we spend the bulk of the time, these are done sequentially, but none of these tasks have a dependency on one another. So wouldn't it be nice if we could do this concurrently? So with the async builder, we can do this. So we're going to start from the very top here. We start by opening a coroutine scope. And this is important because this allows us to perform this parallel decomposition using the async builder. It brings a coroutine scope receiver into scope for this Lambda block that we have. So first we build the async operation, and the second, and the third. And then we await the result of each one in turn. So the nice thing is here is that we've launched all of these things, let them run kind of independently, and then we bring them back together again. So since all of these things can be now done in parallel, things should complete faster. So trying to do this with raw threads by hand would be a lot more code which you would need to maintain along the way. So the async builder is for when we want to run something and then later await the result after kind of giving it a chance to finish while we're doing something else. It's very similar to C# or promises in JavaScript. So what about when you just want to launch something and forget about it, though? Well, there's something for that, too. It's just called launch. It works pretty much the same way. So in this case, it's a lot more similar to executors and just sort of submitting a task, submitting something to an Android handler, for example, when we just want to fire and forget and deal with it later. So that's a little bit about the basics of running coroutines in isolation. How do you run them on Android, though? So in this case, you might have an Arch Components view model. And wouldn't it be nice if we had kind of an easy way to put all this stuff together automatically? We needed to be able to open a scope. So where do you get one of those things to begin with that you can launch things into? Well, in this case, our view model has a show repository, which is our data layer, and we have a view state that the view or activity or fragment can observe. We can refresh on construction, and when we actually go to refresh, we launch into this new view model scope extension property. This is coming very soon to the AndroidX libraries. Those of you who like to watch commits in AOSP might have seen this going already. So the refresh function launches a coroutine uses the launch builder, which then calls the update function on the repository. And our coroutine resumes back on the main thread after update show returns, so we can safely manipulate our view hierarchy with the results just on the next line of code. We have this nice, clean, sequential ordering of operations. So those of you who want to go check out this thing that's upcoming, you can go to this link, take a look at the change so far in advance of the actual release. This is coming in an upcoming release of our KTX libraries. So let's go ahead and demystify how some of this works a little bit. But before we can go too deep, we need to start talking about some of the other primitives that are at work under the hood here.
Thank you.
Whoa. Oh, we lost our deck.
Oh, Keynote crashed.
Uh-oh. Did we switch to the wrong?
Yeah, oh, Keynote.
Keynote crash.
It's on the, OK, we good? OK, great. So we're going to talk about jobs a little bit. So what is a job? So here, when you actually look at this code snippet, the one we just looked at from Adam, you're actually using the launch method. Now, when you actually run that launch method, it returns what we call a job. Now, job allows us to keep a reference to that ongoing piece of work. And it has really one method on it, and it's called cancel. Now, obviously, in this example, we wouldn't just call cancel straight away after we've launched something. That would be ridiculous. But what it does allow us to do is handle something like double refreshes. Like, if you have something like pull to refresh in your app and an automated refresh, you don't want them both to happen at the same time, and then you have two things happening at the same time. So here, this code snippet, you can keep a reference to the one that's currently running. And if it happens again, like a refresh is called, then you can cancel the first one. And so that's the kind of how job kind of works. It's a very simple object, but it allows you to keep a reference to the ongoing piece of work. So you may have seen that view model scope thing and wondered what it is. Adam explained it earlier, and that you can have a scope, and it provides you with all the context you need to run a launch or an async. So let's take a look at how they actually work underneath. So coroutine scope is an interface that allows objects to provide a scope for coroutines. Think things like things with a life cycle, so fragments, activities, view model even. They can provide a life cycle for the coroutine itself and start and stop it as it needs. Async and launch used to be sort of global methods, and now a recent refactor brought them as instant methods on the coroutine scope. What it means is, mentally anyway, is that instead of just launching something, you're launching a coroutine on X. So I'm launching a coroutine on the activity. It just changes it mentally in your head in that it's tied to the lifecycle of something else.
Right. If you're used to working with the lifecycle owner in Arch components so far, you know the lifecycle owner has a lifecycle that you can then observe and attach things to. Similarly, a coroutine scope has a coroutine context that carries along everything necessary to know how to launch a coroutine.
Some of the stuff we're going to talk about in a bit. And similarly, coroutine scopes provide a default context. So you can provide a default context for all the coroutines that run on it. So think things like what kind of thread pool or dispatcher it runs on, the job, the parent job that allows you to cancel it later, and other things which you can add to it. It's basically a map of context. And it's crashed again.
Oh, it's a good day for slides.
It's just, I think we're back. OK, cool. So let's take a look at another example. This time, we're not going to use view model scope, the automated thing we've added to AndroidX. We're going to write it out ourselves. So here you can see that we've created a job. And now it's just a simple instantiation. We're just going to keep a reference to it. And then we're going to keep that create a coroutine scope using our job. And that means that anything that runs on it allows us to track back using that job object. We're also going to give it a default dispatcher. We're going to talk more about that later. But basically what it means is that anything that is launched on that scope will be automatically run on the main thread, Android main thread, in this example. So once we've done that, we have our refresh method again. And this time, instead of that view model scope, the automated thing, we're going to use our own created scope. And again, it's exactly the same code. We're just using a different type of scope this time. But this time, the launch will be scoped to the job object we created earlier, which means that in uncleared, which is the callback we have in view model to actually, when it's been torn down, we can actually just call job.cancel. And that means that any coroutines which are currently running when the view model goes down will be cancelled at the same time. It reduces memory leaks or whatever it is, just allows us to tidy up. So if you actually have a look at how things are run now, so we've launched our coroutine, and now we're going to go into our update show method. So here we are in our coroutine, so our launch, which is modeled by that blue thing going around. Now here we're in the update show method, which is denoted by the yellow arrow. So we're going to go past that first piece of code, which is the async builder. At this point, we have a first coroutine running, which is our async, and that's doing the local show store stuff. So it's running nicely, and it's doing its thing. Now the outer coroutine is going to go past that and go past the second async, which is the remote. Here, again, so we now have 2 coroutines running, and they're both, well, we have 3 coroutines running, but 2 inner ones, 2 child coroutines. So once they're launched and they're running and going along, we forward on to the first await. Now at this point, we're waiting for that first async, the local, to actually finish itself up and then return a result, which is what await will return. But at this point, because we're waiting on that first async, the outer coroutine is what we call suspended. It's just sat there doing nothing. But during that time, that view model has been torn down. I don't know, the activity's gone away or whatever it would be. And we've called job.cancel. Now at this point, the outer coroutine is cancelled, and then the inner 2 are also cancelled. And now that's something that coroutine scope gives us, and scoping in general gives us for free, in that child coroutines automatically inherit from its parent coroutine. So if the parent coroutine's been cancelled, anything below it will also be. That's some of the nice stuff that's been added recently. But what if you're not actually using view models? A lot of us might not be using it, and we have other APIs which allow you to do similar type of things. So as part of the Android architecture components, we added a listener functionality for lifecycles. So here's a very quick example of how you use them generally. You create a lifecycle observer, and in this example, we're using default. And when you create, and it has methods for each of the different lifecycle events, so on create, destroy, stop, start, whatever it be. And to actually use it on like an activity or whatever it be, you create an instance and you add the observer. Hopefully you've seen this API before. So let's build a kind of scope-aware lifecycle observer, which allows us to scope coroutines to an actual lifecycle instance. The primary API we'll use here is that we'll pass on a Lambda, and that's the thing that we run once we've, say, been started, which is kind of what you want usually most of the time. So we'll now look at our implementation. So the first thing we want to do is on start. So that's when we'll start running our kind of piece of code. So we'll create a coroutine scope using a job, and then we're going to run it on the dispatches.main. You can choose what that would be. And then we'll call script.launch, and then just call our Lambda. Pretty simple, really. And then finally, and on stop, which seems like a good lifecycle to use, that we'll call, well, in that piece of code, but we'll eventually cancel the job. And that will mean that coroutine, if it's still running at that point, will be cancelled. So if you can see, that code isn't actually that complex. Like, OK, it's now in AndroidX, so it's not nicer to use. But if you look at the sort of deep down of it, it's actually pretty simple. And then to actually finish it all off, we'll provide a nice builder function. And you pass it to Lambda, and it will automatically add the observer for you. And what it allows us to do is stuff like this. So here we have a details fragment. And in onVCreated, we will use our livescope extension function and then just run something. And that will automatically be started when we get to, well, it will be started when we go at start on the fragment, and then it will be closed or ended when we get on stop. Right. That brings us on to cancellation.
Right. We've talked a lot about this idea of canceling a coroutine, but what actually happens when this thing cancels? I mean, if you just have kind of a block of code that's running, what gets torn down? What do you need to do to sort of clean up? So when a coroutine is canceled, if it's canceled while it's suspended, so it's waiting on something else to happen, in callback terms, the callback just hasn't been invoked yet, it'll throw a cancellation exception, or rather, the coroutine will resume from the point that it was suspended with a cancellation exception. So what does that actually look like? Here's our example from before. So what happens if we need to clean something up if this is canceled in the middle of that update show function? Well, because it throws a cancellation exception, this is something that we kind of know how to do already. Plain old finally blocks run as expected. We didn't have to add any new concepts beyond what we already know from the rest of Kotlin. But if blocking code is running, cancellation requires some explicit cooperation in order to stop what it's doing. So we can check for that cancellation explicitly in a couple of ways. Generally, this means checking to see if your coroutine is currently active in one way, shape, or form. And there are a couple of useful patterns for doing this. So one of those patterns is that if you know that your job is already canceled, you can call any one of the stock suspending methods, such as yield, used as the example here, to force a cancellation exception to be thrown, relying on that standards implementation that I mentioned before, that if you're canceled when you're trying to suspend, then you'll resume with that cancellation exception. So we know that this will immediately throw if we happen to be canceled. But if you're in a tight loop, you can also just check this is active that's available from any suspending scope, and you can just simply stop what you're doing. There's no reason to really involve an exception here if all you're doing is some sort of tight inner computation loop that you need to break out of. Which kind of leads nicely up into how exceptions are handled with coroutines in general. And there are a few things that are really worth pointing out, especially if you followed some of the Kotlin X.coroutines development leading up to release, because there were some really significant changes that happened. The first is that launch will rethrow unhandled exceptions as they happen. So more precisely, it fails the parent. It cancels its parent job. The parent sees a cancellation exception with the original exception as the cause in the exception object itself. So similar to a thread, they get dispatched to the default exception handler at the root of a job tree if nothing else manages to handle that. But your coroutine context also gets a chance to intercept. You can attach a special element to the coroutine context itself that you can use to handle unhandled exceptions. So let's go ahead and see how that works. Here's, again, our example from before. And say that save show throws a very domain-specific exception in this case. So in this case, this will be treated like an uncaught exception at runtime, just like anything else that throws an uncaught exception on your main thread. So async is a little bit different. If an exception is thrown while something that you launched with async is running, it'll hold on to that exception and only throw when the caller calls await. So coming back to our example from before again, let's go ahead and use what we know. We throw our exception from one of these async jobs. But that gets thrown from this call to await itself. So we know exactly where we need to try and catch that exception, just kind of in the normal way, and handle that error. But there's a gotcha here, and that's that async works the same way as launch in terms of how this nested job tree is handled. The deferred object that it returns is just another kind of job, and so it'll cancel the parent if it fails with an unhandled exception, just like launch does. And it'll do this even if we did an await and called it. Now, this is kind of important because if something throws an exception, it's really important that your app know about it. Like, it shouldn't just disappear into the ether. But at the same time, it kind of defeats the purpose of the code in this sample here. Like, we caught it. What are we supposed to do here? Well, in this case, instead of using coroutine scope at the top to open up this parallel decomposition, we can use supervisor scope. It works exactly like coroutine scope, except with a supervisor job, which is a special kind of job that won't be canceled if a child fails with an unhandled exception. One more spot. Yep. It will only be thrown from this await method here.
Cool. So earlier we mentioned that we can actually decide where coroutines are run and what kind of thread they run on. Because actually on the JVM and on Android, we actually still run on threads. It still uses a thread pool underneath. So we still can decide where that actually gets dispatched on. Now let's have a look. So here we have our launch, a very simple launch, which is missing a scope. But just look at the example. Now default actually is that the context will be using what we call a dispatcher.default. That's a default dispatcher that's kind of given for you for free, and it's supposed to be sort of default for everything, really.
It's essentially a computation thread pool if you're used to using that from RxJava.
So what is a coroutine dispatcher, which is what it basically is? Well, it's the thing which runs and schedules coroutines, as I mentioned earlier. It schedules a coroutines to run on something, on a thread in our case. Now, dispatchers.default, which is the default which you get, is that it uses CPU count threads. So it has, say your device has 4 CPUs in it, you'll get a thread pool of 4, which isn't so great for things like I/O. So most apps will be doing a lot of network or disk or whatever it be, so it's not so great for that. So yeah, it's mostly more like a computational type dispatcher. But it's also an elastic thread executor, which we'll talk about in a minute, but it's the default. There's also dispatchers.io, which was added fairly recently, and it was designed specifically for blocking I/O tasks. So things that we really care about, network, image loading, reading from disk, database, blah, blah, blah. It uses a minimum of 64 parallelism, which basically means that you can have up to 64 tasks run at a time, which is great for what we need. So yeah, you can launch it like that. But the really great thing about the I/O dispatcher is that it shares thread pools with the default dispatcher. And the point where it becomes great is this. So here we have an example where we have an async, which is using the default dispatcher. And then we're going to load an image on the I/O dispatcher. So we're going to do some disk reading, some kind of load of image, whatever it be. And then we're going to use that result and then process it somehow. It's a computational task. Now, because this is running on the default dispatcher, there is no actual thread switch in there because we're using those shared thread pools. I/O and default uses shared threads. So therefore, there's no actual thread switch, which makes it a whole lot quicker. Then we also have dispatchers.main, which we spoke about a little bit already. It allows running coroutines on the UI main thread. Kind of a nuance with that is that in later releases anyway, it uses service loader to load the dispatcher in your code, which is kind of tricky when we have things like ProGuard, so you've got to be careful with this. But yeah, just be careful. And the thing you need to know is that you need to add the Android dependency, which we spoke about earlier anyway. And then to use it, it's, as we said, just launch and then dispatch.main. So that brings us a little bit onto reactivity. So how many blog posts that you've seen recently anyway can be summarized as this slide? And I myself have been guilty of this. Now, I'm going to make the premise and the statement that most devs use RxJava just because it makes threading easy. So the fact that you have schedule on and you can easily switch a thread or I'll switch multiple threads, and that's why most RxJava is uses. Now, of course, there are going to be people who go top to bottom with chains and reactivity. But I think for the 80% of the cases, it's just to switch a thread. And that's because the APIs that we have, and we spoke about them earlier, aren't so great to use. I'd say that and because of that, most people end up using things like single, maybe, and completable, because that's specifically what they are. They're single one-shot things. Single allows you to always have a type, maybe it's nullable, and completable doesn't have a return type. So they're all pretty similar. But in fact, they only actually exist on RxJava, RxScala, and RxGroovy. They don't actually exist in any other platform. So as I said earlier, then maybe it's more of a reflection of the, sort of the APIs that we have at our disposal rather than the fact that they're needed. So coroutines can actually quite easily replace single, maybe, and completable. They do exactly what you think. And we said earlier about replacing callbacks. They also replace these kind of quite nicely. So here's an example. So we have a retrofit interface, which has a get, and it returns a single, which just returns a list of shows. And the way you'd use that in RxJava is you'd do this chaining. So you'd switch the scheduler using schedule on, and here we're going to use the I/O scheduler, which is provided for you. And then we're going to do some calls to when it's finished. Now, the nice thing about the Rx2 interrupt library of coroutines is that you can actually use that exact single as an await. So you can actually use it as like a suspending deferred. So it's really handy for when you're kind of slowly migrating towards coroutines and you don't want to change everything from day one. You can actually keep those interfaces or those observables, and you can actually just call await on them. The receive inside can be using coroutines. So it's quite a handy way to slowly migrate. But what would it be great if we can actually make that retrofit call just a suspending function and just remove the whole Rx from the start? Well, we can. And that is actually coming to retrofit soon. Jake has a PR, which is pending review, but he tells me it's soon. So yeah, it's coming soon. And then if we look at our consuming code, it's pretty much the same. It's just we can now get rid of that await. And it's just a normal suspending function that we've called, and it's just a normal coroutine. And that brings us on to our final section, which is kind of bringing it all back together and trying to think of two scenarios where we show you how to use coroutines to make your lives easier on Android. Both of the examples are all about location. The first one is about actually getting the last known location, which you can kind of think is like a one-shot callback. So here we're going to use the Fuse Location Provider client, which is from the Google Play Services API. It's actually kind of cool because it combines all different providers we have, like Wi-Fi and GPS and mobile and whatever it is, Bluetooth. It provides all those providers for you into one single API. So it's actually a really nice API to use. And it returns a task, which is a kind of future-y type thing that Play Services library has. And yeah, so you call client.getLastLocation, and it returns a task. And from the task, you can add what we call a complete listener, and then you'll get the result back eventually. So it's completely async. So when you think about it, what we're doing is converting a callback API into a suspending function. That's pretty much what we want to do. And luckily, the coroutines library has two kind of builders that do exactly what we want. The first is suspend coroutine. And what you do, you pass a lambda in, which allows you to set up your callback. So basically what we'll do here is call play services and go, get me the last location. At that point, the coroutine immediately suspends waiting for the result to come back. And then the callback can wake it back up, basically. So we'll go through an example now. Yeah, you're given a continuation to later resume. That's how we do it. And how you pass the result back. Analyze the call to cancel the call. Sorry, actually, that's a different one. So there is another version. Sorry, didn't mean to skip that. There's another version called suspend cancelable coroutine. It's like a little add-on on top. And it allows you to cancel the call. So say your coroutine is canceled, you can then tell the underlying API, in this case play services, to cancel its call. So let's build our function. So here we're going to have a suspending function called getLastLocation, and it returns an actual location. It doesn't return a future or anything like that. It's just a straight-up location. So we're going to use our suspend cancelable coroutine builder, and then we're going to have a continuation. That's our kind of callback-y type thing. And then we're going to sort of set up. So we're going to call a location client, which is the play services API, last location, and then we get a task back, and then we're going to add our onComplete listener. At that point, we are going to wake up our coroutine. So that is how we pass back to the suspended coroutine the result, and it then wakes up, and the suspended function basically wakes back up, resumes. Now, because this is a cancelable, actually, back a little bit. Because we are using task, we're not using the success listener, we're using the complete listener, which means that the task itself can throw an exception. Like, it can fail for whatever reason, so you don't have location permission or whatever it would be. Now, it will raise an exception on you, which means that you can populate that back up to the callee, which is done with the resume with exception method. And finally, because we're using suspend cancelable coroutine, we need to tell the play services API that we've been canceled, so therefore it should cancel. So we do that with a callback, which is invoke on completion. At that point, as soon as you know that the coroutine has been canceled, which means that you need to tell play services. Now, this API doesn't actually exist because play services doesn't have a cancel method, but imagine it just exists. Now, Adam's going to talk about observing.
Sure. So what happens when you want to observe a sequence of events over time? Now, this is the thing that Rx is really, really good at. Like, if you're using Rx for anything, it should be for this. And people tend to compare Rx Java and coroutines quite a bit in blogs and so on and so forth. So what does it actually look like if we try and emulate this using coroutines as a primitive? So play services location API, in addition to letting you get just kind of a one-shot, what's my current location, it lets you request location updates using a callback that's invoked multiple times. So normally this is a prime candidate to be an observable. You register a callback at subscribe time and unregister when that subscription is disposed. We get this composable control over shutting down the updates really cleanly. So Rx is a great library, offers a ton of functionality to build things like this. So how many similar benefits can we get if we base this off of suspending functions? So let's, again, start just writing a simple function, or at least it's going to start out simple. Suspending functions don't return until their work is all done. So there's no disposable or closable returned by it, since the calling scope itself is cancelable. We just don't return until we're done. So our observer, in this case, can just be a simple lambda that accepts a location result. And we'll go ahead and call it whenever a new location is reported, without actually returning from observed location. So if you take in this giant pile of code here, some of you might notice that it looks an awful lot like an observable.create call from Rx. So let's go ahead and take it apart piece by piece. We'll go ahead and start off, and we'll just create this done signal that we can await on later to know when to finish normally and clean up. So this is like our observable completion. In the case where you have a stream with a well-defined end signal, you can complete this to let the observe function clean up and return, and we'll see that in a little bit. So the next piece here, where we're creating the location callback, this should really be no surprise. We need one to receive updates from the location provider. But what's interesting here is that we use launch to call the observer function on the same coroutine dispatcher that observe location was called on. Remember, the coroutine scope that we opened here carries along the dispatcher with it that it was called with. So we always know that we're going to call the observer in the same place that the caller wanted the information reported. So We cancel the old job from before and start a new one. We make sure that we call the observer while we're holding this suspending mutex. And this keeps things serialized to make sure that we don't have 2 calls to an observer active at once. We assume that onLocation result won't have multiple calls active at once either. So this is kind of an example of some of the things that if you're building one of these things yourself, this is one of those comparison things of like RxJava kind of does a lot of these things for you. But with coroutines, we have all the primitives to build it. We just need to do a little bit more of it by hand if we're putting one of these things together. So we register our callback, and then we await on our done signal. And since we never complete it, I mean, when does a location stream really complete anyway? This will go ahead and wait for the calling job to be canceled. So we remove the callback in the finally block, so it'll happen on cancellation. And then request location updates normally takes a looper instead of something like an executor, which is kind of unfortunate, because this pattern really shines when you can avoid an extra hop. So if you use like a direct executor that'll just go ahead and run the observer wherever the update happens on the incoming binder thread or whatever it is, it really kind of shines when you can avoid those extra hops, but you get the idea. So here's what it looks like in use. And if you take a look, this looks an awful lot like just a for each call on a collection, and it behaves exactly the same way. So since we used launch to call the observer block in the first place, if the inner block throws an exception, that means that the observe location call itself will throw an exception into that outer scope. We can just wrap this whole thing in a try-catch, and that's all of our error handling that we need to do. So it's a child job, so it'll cancel the parent scope with the exception as well, the same scope that wraps the whole of the observe location function body. So it'll resume from the await with the cancellation exception, unregister the location callback from the finally block from above, and all of this just composes. So you, again, can lean on all of these constructs of the language that you already know by just adding some of these suspending primitives.
Cool. So let's wrap up a little bit. So what's next? What's some action items for you to do? Well, the first is that, as you saw in the keynote earlier, we actually have a code lab specifically for coroutines. And that was released about 3 weeks ago, which is a really good introduction into coroutines and how to actually use it in your app. And secondly, read the manual. I don't like to do that usually, but the docs are actually really, really good. They're on GitHub. You can look at them. You can even edit them if you want to. But they're all very use case based. They're all like, I need to do X. How do I do it? So make sure to go and check it out if you are using coroutines. And that is it. Thank you very much. Guess we'll walk off.
Say hello to Android Things 1.0, Google's managed operating system for building and maintaining Internet of Things devices at scale. I'm Wayne Pekarski, and today I'm going to explain what's new in version 1.0, how it provides long-term support for production devices, and a new lineup of system-on-module hardware. So what is Android Things? Android Things is Google's managed operating system that enables you to build and maintain Internet of Things devices at scale. Provide a robust platform that does the heavy lifting with certified hardware, rich developer APIs, and secure managed software updates using Google's backend infrastructure, so you can focus on building your product. Version 1.0 is the first release of Android Things that is ready for your production devices. We just recently completed our developer preview, and the preview SDK was downloaded over 100,000 times. Developer feedback and engagement has been critical in our journey towards 1.0, and we're grateful to the over 10,000 developers who've provided us feedback through filing bugs, attending events, and posting in our communities. A core part of our OT platform is the supported hardware, based on a system-on-module or SOM design. So what is this? A SOM is a fully integrated component with CPU, memory, Wi-Fi, Bluetooth, and flash storage that you can just drop into your final design, just like you would use a library when writing software. The SOM is certified by Google, and we provide a board support package that includes the kernel, drivers, and libraries to support Android. With Android Things 1.0, we've announced support for SOMs based on designs from NXP, Qualcomm, and MediaTek. And these modules are certified for production use and available in quantities to make real consumer products. If you want to try Android Things right now without buying a SOM, you can even use any one of our developer platforms, even the Raspberry Pi 3. And this highlights an important feature of Android Things. It's quick and easy for prototyping, and when you're ready for production, there's a clear path to buying SOMs in small or large quantities, depending on your needs, and then your software is ready to go. You can then design your own printed circuit board, or PCB, to connect your hardware to the SOM. When building IoT devices, maintaining security is very important. Providing timely software updates over the air, or OTA, is a fundamental part of that. And stability fixes and security patches are supported on production hardware platforms, and automatic updates are enabled for all devices by default. For each Android Things version, Google will offer free stability fixes and security patches for 3 years, with additional options for extended support. Even after the official support window ends, you'll still be able to continue to push app updates to your devices. You use the Android Things console to upload Android APKs with your updates, so the OTA mechanism can push them out to your devices. You can initially experiment with 100 active devices for non-commercial use. When you're ready for mass production, we'll provide you with a distribution agreement, and now you're ready to sell your devices in large quantities to the public. With Android Things, you can build apps using the rich framework provided by the Android SDK and Google Play services, including the same UI toolkit, multimedia support, and connectivity APIs used by mobile developers today. You can also easily integrate your apps with popular Google services like Firebase, TensorFlow, and Cloud IoT Core. This is done using the many existing Android client libraries.
The Android Dev Summit lineup is full of talks on the latest and greatest in the Android developer world. Now, if you're itching to try out what you've actually seen, check out Google Developer Code Labs. Code Labs are hands-on, step-by-step coding tutorials for Google libraries, APIs, and technologies. There are over 70 Android Code Labs, including Code Labs for Android Jetpack libraries and Kotlin coroutines. Code Labs are also available for all skill levels, whether you're just starting out as a developer or a seasoned professional. The best way to master a new technology is to do it yourself. Find your Code Lab and learn something new today at g.co/codelabs/ads18.
Hi, everyone. My name's Nate, and I'm here from the WebView team. And I'd like to talk about some modern WebView best practices, or as I like to call it, using WebView like it's 2018, because it is. So before I dive into what's modern with WebView, let's talk a little bit about what's old. So WebView's been around since the very beginning. It was added back in API level 1, and it changed in a significant way starting with Lollipop. It became updatable, the implementation was. And this was great because it meant that users could benefit from security fixes and bug fixes. It would update every 6 weeks, just like your browser. But a lot has changed since then, too. We've added 40 new APIs just to make it easier to work with WebView, to help developers. OK, but what's really changed? Well, when we look out at the ecosystem, it seems like apps are kind of using WebView the same way they've always used it. And when you look at Stack Overflow, the answers are outdated at best. They certainly aren't best practices, and oftentimes they're just wrong. But some of the blame is on our shoulders, too. Our API docs are written like it's still API level 1, and everything has changed since then. So something that we did is we looked over the past year, and we looked out at the Android ecosystem, and we looked at the devices that are out there today. And what we found is that although we added, for example, on NuGet, we added all these great APIs, a lot of apps can't really take advantage of them because they only run on the NuGet devices, and that's less than 50% of devices today, and it's been over 2 years since it came out. But what we also saw is that almost 90% of devices are running Lollipop, which means that they're taking WebView updates, and it means that this WebView implementation on the device actually implements all these new APIs. They just aren't exposed on older platform levels. So we thought, can we do better? So over the past year, we worked on our AndroidX library. We launched a new AndroidX library, and we're pretty excited about it. And the basic idea is that we're going to bring all these brand new developer APIs, but we're going to try to give you the device coverage you need. And we're going to support Lollipop and above. We're going to do this by leveraging WebView's update cycle. But we also spent a lot of time on this library to make sure it's really usable, that you can actually use these APIs to do productive things. So we designed them to be fairly straightforward to swap out from the framework's APIs. All right, so this all sounds fine, but how can we actually use this to make your apps better? So let's take an example. Since the very beginning of Android, we've given apps a lot of power to customize WebView's behavior. And in particular, we added a callback called should override URL loading. And the idea behind this callback is that you could choose to, for certain navigations, cancel these in the WebView and dispatch them to a different app instead as an Android intent. So the example is you might have a YouTube URL, but that might be better suited in the YouTube app. And this sounds great. A lot of apps took advantage of this, actually. But there was a problem with the API. We didn't get it right the first time. The issue is that JavaScript can trigger navigations. And what we found is that there's some malicious JavaScript out in the wild which actually tries to exploit this app behavior. And from the user's perspective, they might be reading some web content, and all of a sudden, without necessarily their interaction, it starts opening up some new Android app that they're not trying to open. So we actually already fixed this issue. We fixed this back in NuGet, where the idea is we expose this notion of user gesture. Did the user actually trigger this navigation? And it actually works really, really well, but it only works on these NuGet and above devices. And these before NuGet devices are still vulnerable. So we thought this was a great candidate for our AndroidX library. The idea is we're going to expose this user gesture, but we're going to do it all the way back to Lollipop. And this means that you get this device coverage for all these devices, and you can provide this safe experience to your users. But we also made sure that this would be really easy for apps to override. There'd be no confusion. So I think we succeeded, but let's take a look at the code. So before NuGet, here's kind of what our code, what a lot of apps code might have looked like. We're overriding should override URL loading. We're setting a WebView client. And in the body of this, we might be dispatching intents. And this is the insecure version of the API, but back in those days, this was the best we could do. Some of the better apps out there, when NuGet was released, might have something like this. So you're overriding the old implementation from before. And this is for those before NuGet devices. But for the new devices, you have this new implementation. And we're checking user gesture, and we're not launching an intent if we don't have user gesture. So this seems great, but it only runs on a small number of devices. Even today, only 50%. So here's how it looks with AndroidX. And the first thing I want to point out is that almost nothing changed on this slide. And I think that's really beautiful. It means all the code that you already wrote to handle the old framework APIs, that code's all the same. The only difference here is that we're importing our WebView client compat class from our AndroidX library. And we're setting this compat client. And the idea here is that when you're using the compat client, all these callbacks will get, instead of only invoked on NuGet and above, they'll actually get invoked all the way back to Lollipop. So you're going to get the device coverage you need to provide your users a safer experience without really changing a whole lot of code. This is just one example of what we have to offer in AndroidX. So I'd really like to encourage you to go check it out and see how this can help you make your app better. We're giving you the device coverage you need to actually use these APIs, but we're going to have a lot more APIs available. Some of these are going to be small improvements on classic APIs, like we've seen, but some are going to be for entirely new features, like safe browsing. And the best part is that this isn't some soon-to-be-released library. This is already out there. You can go home, you can add this into your apps, and it's ready to go. So you can try out our 1.0 release. Now, I'd like to take a minute and shift gears a little bit. So we've kind of looked at the AndroidX APIs, and these seem great. They're going to give us new APIs with pretty good device coverage, almost 90%. But what about these APIs that have been around forever? These have 100% device coverage, but some of them are kind of hard to use. Even I struggle to use them correctly, and I work on the team. So a common use case that we've seen is loading in-app content. And the idea here is that you want to display some content in your application, but you don't necessarily want to fetch it over the internet. You want to just compile it right into your app. But you also want to continue to build this content with web technology. You want to use HTML, JavaScript, CSS. And WebView has had pretty good support for this. In fact, we almost have too much support for this. We have so many APIs that it's hard to figure out which one is actually the right thing to use. And some of them have some weird gotchas that make them kind of hard to use. So I thought maybe we could take a look at some of these APIs and talk about what's so tough about them and recommend some best practices. So you don't have to start from scratch with a new API, but you can kind of tweak how you're using these. So the first API we can look at is load data. And the basic idea here is that this is going to accept some HTML content. It accepts it as a string, and it's supposed to display this in the WebView. But one of the gotchas is it doesn't really accept HTML content. It accepts encoded HTML content. The idea is you need to escape some special characters. You replace them with a % and code following it. And we call this percent encoding. And this is the default configuration for the API. But there's actually no framework API to do the percent encoding for you. It's kind of an oversight. But the end result is that what we've seen is that developers tend to actually do this percent encoding by hand themselves. And this is manual. It leads to bugs. And these bugs can have significant impacts for your application. One small bug might seem OK today, but it might break in a future WebView update if you forget to encode a particular character. The other issue with load data is this thing called an opaque origin. So when your content gets loaded, it has what we call an opaque origin. And this means that it's going to fail all same origin checks in the web. And these same origin checks are actually critical to providing powerful web APIs securely. Without these same origin checks, you can't use great APIs like XML HTTP request. So what can we do with this API? Well, first off, we can actually escape some of these encoding-related problems. It turns out this API has always accepted an alternate encoding scheme called base64. And this actually isn't that special of an encoding scheme. It's just a different scheme. It's not necessarily better. But it's kind of nice because there's actually a framework API which will do the encoding for you. And it does it correctly. Great. This is base64.encode to string. This will take the content and spit out the right answer. And frankly, the only reason it's not documented is because this came out in API level 8, which today is ancient history, but was still in the future at the time of writing load data. But we can also take a look at these same origin restrictions. So the way we recommend to get around this is to use something called load data with base URL. And one of the nice things about this, I think of it as a feature, not a bug, is that it actually accepts content as is. You can actually give it content that's even totally unencoded. You don't even have to worry about the base64 stuff if you use this API. The other really nice thing about it is that it has this thing called a base URL. And although you're displaying this HTML content that you pass in as a string, the base URL kind of configures this origin that it operates with. So you can control which origin you get without disabling important security settings just to make APIs work. So how do we actually choose the right base URL? So this is something that even I struggle with when I try to use this API. I know it's the right thing, but I actually don't know what the right thing is to pass to it. So I actually thought, how about we go through some of the common use cases? So something that we've seen is that a lot of apps use cached content. This is content that they may have downloaded from the web over the internet, but they're saving it for later, and now when they show it, they need to show it with the right base URL. And the right URL to choose is just the original URL that it came from. This guarantees that if it worked originally, it's going to have the same exact origin, and all the APIs are going to continue to work. The other use case that we've noticed is that apps tend to ship their own content and display it this way, which is great. What we would recommend is that you choose a real internet-type URL, one of these HTTPS or HTTP URLs, and it should use your organization's real domain. And the reason for this is so that you can import other resources from your servers and use them in this content without worrying about any same origin checks. It'll all work. And then there's the question of, well, do we use HTTPS or HTTP? So here's a little rule of thumb. We always want to encourage HTTPS. This is the secure protocol. But if you do need to show insecure resources, we'd recommend that you use the HTTP scheme as opposed to disabling important security settings just to get your app working. And as a last point, I want to urge apps to avoid custom URL schemes. So this is something that we've noticed has cropped up. Apps will kind of make up their own scheme and use that. But the problem with this is that the web standards don't really expect custom URL schemes. So they're very vague about how to handle this. And it turns out that they wind up getting handled very inconsistently. And this can lead to surprising app breakage. So if you can stick to one of the internet URL schemes, you're going to have a much better time. So hopefully I've kind of expressed that we really do care about developers at the WebView team. And we're trying very hard to make sure that you have powerful APIs that have the device coverage you need, while also paying attention to some of these old APIs and making sure that we explain how these need to be used, making sure that they're actually usable. If you have any questions, me and my colleagues will be around for the rest of today, as well as tomorrow, and we'd be more than happy to talk to you about WebView usage and what you need for your application. Thank you very much.
Introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development.
So you know that no matter what platform the user is on, tasks are scheduled efficiently and with system-wide health in mind.
And we're just getting started.
Be inspired. Isn't that something?
Learn to architect and develop Android apps in the Kotlin programming language using industry-proven tools and libraries. With these techniques, you'll create apps in less time, writing less code, and with fewer errors. Creating Android apps in Kotlin is a course developed by Google together with Udacity. The course gives you hands-on experience as you build real Android apps using industry best practices with modern app architecture. You'll learn to use Android Jetpack components such as Room for databases, Work Manager for background processing, the new navigation component, and more. You'll use key Kotlin features to write your app code more quickly and concisely. Learning to develop on Android is much more than learning APIs and shortcuts. It's training your brain to think like a mobile developer. Come learn with us. For more information on this free course and to see all of Google's courses with Udacity, go to udacity.com/Google.
Hello, hello. My name is Don. I work in the Android DevRel team, and I'm here today to talk to you about low latency audio on Android. So, why is audio latency important? Well, there are a whole raft of use cases where the audio latency is directly proportional to the user experience. So, this can be in games, where you tap on the screen and you hear a sound, particularly in rhythm games like Guitar Hero style games, where you're tapping in response to some rhythmic event, and you need to have audible feedback as quickly as possible. Like, the longer the delay between tapping on the screen and hearing a sound, the worse the user experience. Also in DJing apps, you're tapping on the screen and manipulating audio, and you expect that audio manipulation to happen in real time. Karaoke, where you've got an input, which is your voice, and generally you're listening to a backing track and also your own voice. So if the delay between you singing and hearing your own voice is too long, then it sounds awful. Also in VR, we have objects which make sound in a virtual world. And if that sound doesn't follow you around as your head moves in this environment, then it kind of distorts the reality. And lastly, of course, there's a whole load of apps for live performance, synthesizers, drum machines, looping apps, anything which you press a key and make a sound, you need low latency audio. So with this in mind, we built a library to help developers build these kind of apps. It's called Oboe, and it's available on GitHub now. We just launched version 1, so it's production ready, able to be included in your apps today. And the way it works is, under the hood, it uses the A-Audio API on API 27 and above, which is the new high-performance, low-latency audio introduced in Oreo. And on older devices, it uses OpenSLES. So basically, the idea is provide a simple, easy-to-use API which works across the widest range of devices. So rather than me talk about this API, I thought it'd be fun to try and build a musical instrument in 17 minutes and 23 seconds. So before I start that, I'm just going to explain the architecture so it kind of makes sense when I'm in the code. So we have an app, and I'm going to build the audio engine part of this app. This audio engine is going to be responsible for creating an audio stream that's provided by the Oboe library. And we're going to be passing audio frames of data into this audio stream. Ultimately, this stream is responsible for putting data out of the audio device. In this case, it will be the 3.5mm jack on this Pixel XL phone. Now, every time the audio device needs more information, it's going to give us a callback. So we get this callback loop of, hey, I need more audio data, and our audio engine is going to be passing frames of audio data into the audio stream. For some form of control, we're going to monitor tap events on the screen. So when you tap down, the sound will come on. When you lift up, the sound will go off. OK. This worked about 50% of the time in rehearsal, so let's see what happens. OK. First problem, I need to log in. OK. Can you see my screen? Fantastic. OK. So I'm just going to run the app. So I've kind of got a very simple shell of an app. It doesn't really do anything at the moment, but it just has a few little shortcuts that make it possible for me to do this in a very short amount of time. So I will just run the app on this Pixel XL, and hopefully you'll be able to see that it does nothing. So here we go. Here's the app. And when I tap on the screen, nothing happens. No sound comes out. It's non-functional. I just want you to know that there's no smoke and mirrors here. It is genuinely live. Thank you, Glenn. OK, so we're in our main activity here. And we're going to talk to the Oboe library via JNI. So I have a couple of native methods here which I'm going to use, and I'll implement those methods in a second. But so we're going to create an audio engine, and we'll start by calling start engine. So let's just jump into our JNI code. So this is in nativelib.cpp here. So I'm going to define an audio engine up here. Just call it engine. And then I'm going to call a method on my engine called start. Now, I've already created the header and implementation files, just the blank files for this audio engine class. So I'll go ahead now and write the class. So audio engine. And I'm going to have one method called start. Okay, now I can use option enter to generate the definition for this. I'm in my implementation, and I'm in the start method. Before I can start using the oboe library, I need to do two things. Number one, I need to include the oboe header. There we go. And the other thing I need to do is, well, this kind of just makes it easier for me, which is to use the oboe namespace. And this just avoids me having to prefix all of the oboe objects with the word oboe. So in our start method, we want to create an audio stream. To do that, we use an audio stream builder. Call that B. And the builder allows us to set properties on the stream. So that's things like the format of the stream. Now, when I set the format, there are two choices I can choose from, either 16-bit integers or floats. I will use floats. I can also set the number of channels. So that would be 2 for stereo or 1 for mono. And I can also set properties which inform the stream of my latency requirements. So the most important one here is set performance mode. And there are a number of options, but the one I want is obviously the low latency one. The second thing I can do is set the sharing mode on the stream. So let's just set that. So I'm going to set this to an exclusive sharing mode. And what that means is that I'm requesting that the audio device give me an exclusive stream. That means that my app's audio won't be mixed with any other audio on the system. So if the device supports it, I can avoid having my audio mixed with anything else before it goes through the speaker or headphones. And by doing this, I can cut a few milliseconds of latency off the output. So that's all I need to do to open the stream. So I can go ahead now and call open stream. This takes a reference to an audio stream pointer. Again, I can use option enter to create a new field called stream. So back in our header, it's done this automatically for me. OK, once the stream is open, there's one final step I need to take, which is to set the buffer size on the stream. So I can do this by doing set buffer size in frames. Now, to get the smallest possible buffer size, we have to interrogate the audio device for the minimum amount of data that it will read in one operation, so a discrete chunk of audio data, and we call this a burst. So we want to obtain the burst size from the audio device. We can do this using stream get frames per burst. And that's the minimum possible buffer size that we can set our stream to have. But we actually don't recommend that you use this absolute minimum. We recommend that you use double this, because it provides a good protection against underruns. It's a good trade-off with latency and underrun. OK, so that's all I need to do to create a low latency stream. So now I can go ahead and start the stream, which will do nothing, because we haven't found any way of putting data into the stream. So to get data into the stream, we use a callback. So I'm back in the builder, and I'll use this set callback method. This wants to take an audio stream callback object, and to make this simple, I'll just use my this object, which means that my audio engine needs to implement this interface. So we'll have it do this. Now I can use Control-O to show me the methods that I can override in this interface. The one I want is onAudioReady. This is the method that will be called every time the audio device needs more data. So inside here, let's just take a quick look at what this method signature is. So onAudioReady is called. It tells me the stream that wants more data. And it also gives me a container array. So this container array, which is of type void star, because it can be either 16-bit integers or floating point samples, is something that I'm going to write my audio data into. So I write it into it, and then that's passed out to the audio device. Lastly, we have num frames, which tells me the number of audio frames which need to be populated in this container array. So I need an audio source, and I'm going to cheat a little bit here. I have created an oscillator in advance, and let's just take a quick look at it, and it's just going to generate a square wave here. So that's a periodic signal varying between 2 points to create a square wave. So let's now create an oscillator. I'll just do oscillator. It's a templated object, so I need to tell it what type. And I'll just include the oscillator header. So now that I have an oscillator, I can do osc render. OK. So Android Studio is complaining about this method signature here. That's why it's got a red underline here. I'm just going to go ahead and build, and that normally sorts it out. Yeah, there we go. OK. Ignore the errors. OK. So on my oscillator, I have a render audio method, which is going to put the audio frames from the oscillator into this audio data array. So first thing I need to do is cast it to this an array of floats, audio data, and pass in the number of frames. So the last thing I need to do in onAudioReady is return a result. And this can be either to continue, where the callbacks will continue, or it can be stop, and the callbacks will stop. So in my case, I'm going to continue. Right, the final thing I want to do is set some things up on my oscillator. So I'm going to set the amplitude, which is kind of the volume. I'm also going to set the frequency, set that at about 80 hertz, nice bass frequency. And I also need to set the sample rate, which tells the oscillator how frequently these samples should be produced. And I can get that from the stream, get sample rate there. OK, I know you're all desperate to hear a sound. There is one very final thing I need to do here, which is I need to respond to tap events. So I'll just go back into main activity, and I'm going to override the onTouch event so that if the event is down, then I'm going to call this native method tap, make that true, else. Otherwise, if the event is up, I'm lifting my finger off the screen, then I'll pass in false. OK, let's just have a look at this tap method. This needs implementing. So I'll just pass in this true or false value, create the new method, and I just call osc set wave on, and that's going to pass that in there. Now, moment of truth. OK, I'm going to run this. And in theory, we should hear a sound. So when I tap on the screen, we should hear an 80 hertz square wave. The pressure. There we go. So you can see it's the lowest possible latency here, and it's actually pretty responsive, which is so we have a musical instrument. Admittedly, it's not the best musical instrument in the world. A little bit to be desired on the sound and control front. So what I actually thought would be nice is if we could add a little bit more control. So for the last 4 minutes and 30 seconds, I'm going to tie the motion sensor to the pitch of the oscillator. So to do this, I'm going to cheat, uncomment some code that I wrote earlier. And what this does is register a listener, which will listen to the rotation vector sensor. So to listen to these events, I need to implement the sensor event listener interface, implement the methods, on sensor changed. So what I want to do is set the frequency based on the event values of the x-axis. And I also need to scale this value. So I want to have it from, let's say, from 20 hertz, the limit of human hearing. And let's go up to like, so this should give me around up to around 100 hertz. So, yep, that looks good. So again, I just need to implement this frequency. OK, so we'll just go OSC set frequency, and there we go. OK, so we're good to go on that. Brief interlude, very brief, in fact. Has anyone heard of the Amen break? OK, one person, yes. So the Amen break comes from a song in the 60s by the Winston Brothers called Amen Brother. And it's 4 bars of the most incredible drum solo. And it's the most sampled loop in history, but no one's heard of it, evidently, apart from one guy. So I thought it'd be nice if I could play my new musical instrument over this loop. So here's the loop. I need to run the app. Let's give it a go. Make sure it's here. OK, so with a bit of luck, here we go. Okay. Right. Yeah. OK, so that's about it from me. If we can just go back to the slides. And yes, so the library's available on GitHub. There's documentation, code labs, all sorts of good stuff on there. We'd love you to start using it, start building amazing audio experiences on Android. Yeah, and I'll be around afterwards if you have any questions. So thank you all very much.
Thanks, Don. With the end of that talk, that is the end of the day, which means it's time for a party. So the theory with the party is we're going to have food and drinks and a DJ. I personally vote for Don be the DJ. I want to hear that tune all night long. Or at least for like a 2-minute loop, and then that's probably about enough. So 6:20, the party starts at 6:20, which means we're
We're introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development.
So you know that no matter what platform the user is on, tasks are scheduled efficiently and with system-wide health in mind.
And we're just getting started.
Be inspired. Isn't that something?
Learn to architect and develop Android apps in the Kotlin programming language using industry-proven tools and libraries. With these techniques, you'll create apps in less time, writing less code, and with fewer errors. Creating Android apps in Kotlin is a course developed by Google together with Udacity. The course gives you hands-on experience as you build real Android apps using industry best practices with modern app architecture. You'll learn to use Android Jetpack components such as Room for databases, Work Manager for background processing, the new navigation component, and more. You'll use key Kotlin features to write your app code more quickly and concisely. Learning to develop on Android is much more than learning APIs and shortcuts. It's training your brain to think like a mobile developer. Come learn with us. For more information on this free course and to see all of Google's courses with Udacity, go to udacity.com/Google.